got a care package. This is everything we got here. This is what we were waiting for to continue the build. So unboxing. So first of all, we have our wire. We have 16 gauge wire, 10 feet, 6 different colors, like 60 feet. And this is tint copper wire. They were nice enough to include some heat sinks actually. We don't have a heat gun, but so we might not be able to use them. And some color zip ties, which I've never seen. That's pretty cool. And so this is what our wire looks like. It's wrapped, but yeah, if you were to compare these with let's see, some of our jumpers that we had before, you know, it's like if you were to compare that with our jumpers here, this thing, man, it's at least like, yeah, it looks like 3 times, 4 times the thickness. So that's pretty cool. So that this will be much better. And I have no clue if 10 feet is enough, but I just thought we would start there. It's not terribly expensive. And we have different colors, even though, you know, I don't know why we want that many colors. Anyways, wires, that was the main blocker. Here we have some switches. I don't have a knife. I have scissors. So these were the switches that we added last minute just to control the power, the on and off. They look very beefy actually, so I've never seen these in person before. And I was concerned that they could not handle enough current. As with anything electrical, you know, it's always a question of how much current it will handle before it melts, basically. So our wires already melted. I didn't want a switch to melt. Obviously, this would be critical because this is the power switch. So if it melts, it means we lose all power and we can risk a short somewhere. So this was important. And it looks like it came with some really nice wires with connectors. So these connectors at the end looks like it would like just slice in here. And then here you can just splice these and solder or connect it to something else. That's really nice because in the past I would usually just solder straight to the terminals and it wasn't as clean. Oh man. Okay, once they come in, they don't want to come off. But these are really nice. Yeah. And again, nothing crazy, nothing fancy. I just went on Amazon, search switches, kind of took a look to see if they could handle, you know, at least a few amps, and I just bought the cheapest. Now these looks like a bunch of jumper cables. I think these are the joysticks. So there was an option that it came with jumper wires for basically the same price as the option with no jumper wires. So always keep an eye out for that. So now we have more of these guys, even though we're graduating from them, so we probably don't need them, but you never know. That never hurts to have those around. Now these are pretty sure the joysticks. They smell super toxic, by the way. It smells super toxic. The way I understand them, the way these are marketed, I think these are PS2, so PlayStation 2 controllers, so like the super old PlayStation. It's like throwback. It does kind of smell like a PlayStation 2, but I don't think these are the exact same joysticks I remember. But anyways, this looks very nice. The feel is very nice, responsive. The spring back is nice. I like these. Easy to mount. A little chunky on the PCB, black PCB. It's nice. And looks like it has a ground, a 5B, a BRX, BRY, and SW pins, which I actually don't know what the last 3 mean, but so that's cool. Now we have the joystick. So with these, we'll build a manual controller so we can like manually drive these around. Maybe go for a walk, meet other dogs. So that's cool. I also got another Arduino, and the main reason for this other Arduino was so during builds, you know, when we're initializing servos, we don't have to use the main Arduino, which is gonna be screwed onto the robot, the torso. And the wires are gonna be set, and we don't wanna be like removing wires over and over, right? So this is gonna be our installation slash prototyping Arduino. And the other Arduino is gonna be our production Arduino. It's the same Arduino, I went with the same board. These are off-brand Arduinos, so these are not official Arduinos, but I haven't run into any issues, and they are like $10. So yeah, looks good. The Arduino Uno is just a little chunky, but you know, if you want anything smaller, there's your Arduino Nano. But if you get the Nano, you do lose some pins. We're using 12 PWM pins, which is a lot, and you also have to solder components, as they do not come with headers. The Uno came with another one of these wires. These are very short, which too short, so like your computer needs to be too close to a robot, and when it's walking, it gets in the way. So I also got a USB extension kit. So this is like 10 feet. So we went from too short to too long, but I think this should probably work. Let's see what else. These things are, I've never used these before, but these are cable labels. So it's like a sticker that wraps around a cable, and you can label what it says. These are a little big. These are too big, right? I want to label every servo, but these are huge. So I don't know. We'll see if we end up using these. I imagine those were cheap. These are connectors for our new wire, so we can connect things properly and securely, and not just like shove them into the terminals like we did here. This is all kinds of different connectors, logs like rings, butts, forks. You know, we have a lot of options here now to properly have some electrical connections. And for these to work, you also have to get a crimper, which actually is not included. And I think this one will work. It's not like, oh yeah, it is the same brand, but it's not like really a brand, right? It's just like some, you know, off-brand from Amazon. But I mean, they look good, I think. Sometimes with cheap crimpers don't work as well, but this one looks okay. We'll see how it works. Everything smells crazy, by the way. It smells like straight from a factory. And I guess the next and last thing is the filament. So I got 4 different colors of filament, which I might regret. So we have silver, we have cyan, which I think it's like a Miami blue if you are into cars. Magenta, which is engineering for pink, and jade white, which is just white. Yeah, so I think it would be way nicer if the whole robot looks one color, but I also thought it would be more entertaining for the videos if we are, you know, cycling through different colors through different iterations, so you can kind of see how parts evolve. So here, if you see this robot right here, you know that the green leg, if you've been watching all the videos as you should have, you know that the green leg is the first leg we ever printed, and all the orange stuff came after, right? So next, I think next we're gonna do blue, and after blue will come white, and then magenta, and then last silver. So silver, because it'll look more metallic maybe. That'll be like our last color, so it'll look closer to a finished product. The other thing is, the reason why I bought 4 filaments at a time, I don't think we're gonna print that much, to be honest, but silver is more like gray, to be honest. If you buy in 4s, if you buy 4 or more, there's like a bulk discount. So I think instead of $20 per filament spool, you pay 15 or something like that. So it's worth it. And the other thing is, when you buy filaments from Bambu directly, you can either buy a reusable spool, so these are reusable spools, or a normal spool, which, so my first spool was normal and it came with these things. The reusable ones do not include these, so it's just they just come with like these, and so these are also cheaper. You can save another $1-2 that way. I've never done this before, so I don't know how you load it like that. Actually, there's instructions here, right? So it's like, basically it says, twist open the reusable spool. Is this a reusable spool? I have no clue. But it does twist open. Find the locator. I'm just gonna show you. Let's see what I'm reading. So it says, okay, twist open. We twist open. Find the locator, a tiny block on the white piece. Which was a white piece. Align it with the notch on the inner ring of the filament roll. Insert the whole piece into the filament roll. Okay, so I imagine they didn't say this, but we should remove these. We're looking for a tiny block on the white piece. This is a white piece, and this is a tiny block. Found a tiny block here on the outer here. And so now you open your filament here. It's vacuum sealed to keep humidity out. It's very important for the filament not to get humid. Else your prints start to fail. Some food here, some snacks for later. I'm joking, don't eat that. Here's a sticker to let you measure how much filament you have left. You already have it here. It's the same sticker as here. I don't know why they included this. All right. So they said line up this feature here with the block here, which makes total sense. Hard to tell if they're lined up, but it doesn't move anymore, so I think it's lined up. Final locator, yes. Step 3, align the triangles on the so there's some triangles here somewhere. Yeah, there's a triangle here. Align the triangles on the rims of each piece and insert the narrow piece until it pushes firmly into the white piece. So narrow piece is this, narrow piece, white piece. Okay, that's one way of calling them. So we line up the triangles, sort of like this. I mean, this is very simple. This is honestly very simple. Tear apart, and then we tear apart the plastic strips. That's honestly really simple. Like, and saves you some money. Why not do it like that? And boom, that's it. And we're ready to go basically. Now, if you've never loaded filament into the Bambu or any 3D printer, actually, I'm gonna do that right now just to show you. I think Bambu is extremely easy. All printers are normally easy. All you have to do is heat up the nozzle, and you basically manually put the filament in, and then you get the it's extruding mechanism to push it for you. Bambu is nice because it basically automates all these steps. So you just click one button and it hits up the nozzle, and it starts pulling also at the right time, so you don't have to do it yourself. It's like slightly easier. In general, it's always easy, but Bambu has made it slightly easier. So I'm just gonna really quickly show you how to do that. Here's our printer. So first step is gonna be to turn it on. There's a switch behind it, the printer. Here's our filament, and it's initializing. I'm just gonna put back this magnetic bed here. You always print on the bed. Makes it way easier to pop out prints after. And I think it's also textured, which helps the prints adhere to the bed. At least I've never had a print fail with this thing on. Now, here you have kind of like the options. This is a P1-S. I think some of the other models have a nicer interface, but you basically, obviously I wasn't prepared for this. This is home. You go on the one below here, you click here, and Also, it's not here. So next one, it's not here either. None of those. So maybe back to home. It's not home. Here, it has to be here somewhere. Okay, 1 second. Maybe the interface I was thinking about is actually on the Bambu, on the slicer side of things. So same thing here. So here on the Bambu slicer, you can on the device tab here, and here you can unload and load, right? So you click on unload. Hopefully, let's make sure we're connected. Okay, so there's no option to unload, but there's option to load. So in order to load, right, we're gonna put our spool in place. And all that means is basically bringing the spool here, making sure it's in the right orientation, right? So the filament, as it comes out, it should point this way, as that's where this is. That's where we're gonna feed it. I usually like to cut these like this. You want a clean edge, basically. So let me grab some scissors. All right, here are my scissors, and cut that, and then I think you can just push this all the way until there's basically some resistance, right? So it's basically gonna go all the way to the end of the tube where it meets the nozzle. The nozzle is not hot right now because we haven't initialized the load command, right? So that's all as far as it will go. So now that we have that, switch it back to place. And I think now we can, now we can just click on load, allegedly. Maybe tell them it's PLA. I don't know, load was green. I swear last time this was very easy. Okay, actually back to the interface. I found it. So it's not in home, it's on the next one here. And then here you go to feeding, you click on this, and then one of the options is gonna be load. So just click on load. And then you'll see the temperature of the bed went to 250. I don't know, I guess you kind of assume it's PLA. So it's 250, so it's heating the nozzle, and it will do its thing on its own. So once the nozzle is heated, you'll see, it's actually kind of hard to see, so I'm taking you off the tripod here. But last time was such a clean process that I just wanted to make a video. It's like this time around, it just didn't work as great. Actually, hold on. We also got this message on the computer. So maybe we confused it a little bit by trying both on computer and on the firmware here. But I think it's good to go. Let's actually try printing something. All right, in order to start printing, we need to create some STL files. So let's do that really quickly. So we usually start printing the torso, right? Because that's basically our biggest part, or all our biggest parts here. Now that we added that belly part. Man, I really dislike the word belly. I don't like that word belly. I was just thinking about this. I watched this movie called The Substance the other night. You should watch it if you haven't. I think the front and the rear are the same still. Yeah, makes sense to me. We don't need to see this anymore. Okay, so we can save we can export one of these as a STL torso bracket B2. This is in B2. This is in reality, it's like B3 or something. But this is kind of like the first overhaul of the entire robot design, right? Previously we've changed like smaller things, but this is the first time we do a big change. So we have those parts. The other thing we should print, you know, last time we redesigned the shoulders here, but that print failed because we ran out of filament. So now that we have a lot of filament, we're just going to go for it. So we'll do that. All right. So now we should have more than enough parts to print. I don't want to start with the shoulders. That's because that one's easy. I think starting with these makes sense. Because we can de-risk a lot of things, like make sure the fits are good and so on. Now the issue is that actually, let's put all the parts here and let's see how Bambu decides to split these. Obviously, it doesn't fit in one plate, but you can slice multiple plates. Oh. Load files as a single object? No. Okay, cool. All right, so in these. All right, and next, yeah, we could arrange it into separate plates, or we can use this function here. You just tell them how far apart you want things, and it does it like that. I think we could have a higher density. Yeah, I'm trying to pack as much density as possible into these plates, so. Rotating things around. All right. That should be, I guess that should be good enough. I like all shoulders in here. An object is like, okay, height limit. I don't know which object. Okay. Well, it's not happy, so. I guess you have to keep clear these block here, the white tiles. But I'm just gonna move back here. Well, anyways, he doesn't want to do it, so. Okay, it's not happy, so I'm gonna let it arrange it itself again, and okay, we'll start printing this plate here, and so just make sure, as usual, that our support is on. It seems to be off by default, and then we slice it. I'm also looking at plate number 2 here. Okay, a lot of support. All right, yeah, I think that's fine. Then we can go print, and we start printing. So let's go back to the printer. Actually, okay, it's send in job. It's a big job, I guess. All right, 156 grams. I think each spool is like 1 kilogram. So it's just it's a good, nice big chunk. All right, so we have the prints going now. it was a bit of a issue loading the new filament, but it's printing blue now, which is it's exactly what I want to see. So so I'm gonna leave. I'm gonna go hiking for the next 2 days, and I'm gonna leave this printing. Hopefully, we'll come back to almost finished parts, and then we can assemble then. So see you then.
2,000 years later.
Let's go back, and the new robot is still not done printing, actually. Of course, the issue is that the Bambu printer is not able to start a new plate of print without you manually removing one. So you cannot print the entire thing over 2 days, right? Someone needs to come and clear the bed. It would be cool if it would just automatically clear the bed and print more parts, but I guess we're not there yet. It's gonna be another day of printing. But in the meantime, I've thought of something else we could do, which I'll get into in a little bit. I just wanted to shout out my camelback. I got a camelback here, so I went hiking for a couple days to Yosemite. You know, maybe did 25 miles over 2 days, maybe 40,000 feet elevation gain. Nothing crazy, but having a camelback is actually such an advantage. Not having to stop to drink water. It's like, it sounds so simple, but this is actually a really good product. And such a small pack can actually fit so much stuff. I think it's a 3-liter pack, and you can fit like everything you need here. I actually was carrying also jackets because, you know, we would be on the trail for 12 hours. You start in the day, and by night it's actually way colder. Yeah, I just want to shout this out. Camelbacks are awesome. Anyways, let's get to work. All right, so well, you'll be able to hear the 3D printer working in the background the entire video here. But something I was thinking, you know, as we start to print this new iteration, different filament color, I was actually thinking it would be nice to also have new legs, so just the entire robot is the same color. And you know, there's a decent engineering reason for this, which is like we've learned how to improve the legs already. You know, we're on the kind of like the 3rd iteration, and on the like 2 videos ago we built this like single part leg, and a lot of the ideas there were actually pretty good, so we could roll those onto the actual production leg, multiple part leg, and it will be a better leg, and also we'll print it with the same new filament, so the whole robot will be the same color. And the reason why I think that matters is because I want to start using the robot to make some content, some like not this type of content, but some like mainstream content, some stuff that, you know, quote unquote normal people would enjoy, or like maybe taking it to the streets and like taking it to a dog park and see how people react to that kind of stuff. And so I do think it's important that it looks, you know, kind of cohesive. So that's why I want to print a new leg. Let me move the camera here. So part 8, this is where we are. So to do new leg design, print entire robot, assemble, move all actuators without burning down. So this is what we're gonna do in this video, right? So new leg design, which is what I'm proposing right now. Print the entire robot. That's happening in the background right now. You can hear it. We're gonna assemble it. This is actually gonna be way faster than last time. Well, first we gotta assemble the existing one and then assemble the new one. This is actually gonna be way faster than the last time we assembled, because now I have a working electric screwdriver and I got some nice attachments that work perfectly. And then we're gonna prove that we can move everything without burning it down. And then on the next video, because this video is, I'm sure it's gonna be like super long already. Then the next video we will take a first step, a hard-coded first step perhaps, and then maybe next after that we can move on to building the joystick. So kind of like those video number 10. Anyways, so this is what the leg looks like right now. I did mention that every leg is its individual assembly, so it's a bit annoying. And we had a separate Onshape file for what we called the mono leg. Best name we could come up with. So the mono leg looks like this. One of the main things to take away here is the foot here, right? So I'm gonna write down the new like design things. New food or feed, food, ESL. So that there was an offset here on the knee horn offset. We also removed the retaining ring. Remove retaining ring. We also consolidated the hip. Consolidate hip servo horn with part with leg, right? So there used to be a separate part here. We consolidated that with the upper, so that happened. And then the other thing that we should, well, okay, and I mean, there's something to be said about removing the need for heated inserts, which is here, here, and here. Obviously, like the most obvious way of removing heated inserts would be to just, you know, make them threaded holes and like put nuts in them. And I think that would work actually. I was a little bit concerned about interferences on the other side because I think the screws would have to overshoot and then would have to put a nut on the other side, not just thread to the plastic, because threading to a plastic, I mean, threading to a plastic might be fine, but because this is a joint and it's moving, it will eventually, I think it will eventually cause the screw to kind of like become untorqued and fall off. So that's why I wanted to put a nut on the other side. So yeah. Let's see. Remove need for heated inserts. Oh, and then the other thing, it's this servo initialization issue. This kind of like iron things out on the joint. Kind of like I never know where is 0, where is 180 for each servo. So we should make it very obvious. Basically, make hard stops obvious and servo friendly. So when assembling the leg, you know, the hip servo would just be, oh, on the hard stop. That's the extreme of the leg structure itself. It's also the extreme of the servo, right? That makes sense. So actually, a lot of work to be done here. It's 4 p.m. right now. I'll try to be done by dinner time. So let's take a look here. We're gonna work on the rear right as always, as usual. We usually work on the rear right. Wait, I think I've gone. I don't know where that's pulling from, but so in this new scenario, we wouldn't need the standard feed. Right, so I think the way we did this last time is we deleted some faces, mostly around, I don't completely remember, but it's like, I think we're trying to make this a rectangle basically. So okay, well, obviously not like that. Actually, just let me go back. Let's not reinvent the wheel. How did I do this last time? Here, this guy. Oh, okay, I remember now. I have an archive part. We had to like export it twice or something like that. There was a whole thing. Okay, so all right. So step 1. Deleted the food itself part, and then okay, so I just tried doing that, and then here Okay, so first the sketch though. Sketch. Yeah, the sketch is based on food. Keeps roughly the same geometry. That makes sense to me. What radius did we settle on? R35. I see. Just gonna write that down. We can use basically this similar idea, right? I think it was like 30 degrees radius arc, 30 degree arcs. So this is the part, but I'm gonna edit it in context just because. Oh, actually, yeah, I'm gonna edit it in context here because we don't have the food in this document. And so in theory, if I do these, that will work, right? I think that didn't work. Did I miss one surface? Yeah. And that works. It's kind of awkward. Okay, I'm not gonna do it like that. I think it's not working. Let's jump straight on to needs a flat surface. Is that a flat surface? Yes, that's a flat surface. That's a right. That's a flat surface. Let's jump straight onto a point here. So make this a middle point, right? So, so in theory, you can draw a line from this point up to somewhere like here, I think. And then you can have a circle, and then the radius is 35 roughly. Sorry, that's diameter. Okay, I see. So this is how you know we've done something different. Diameter is 70. So by default, I think any CAD software, you know, if you're dealing with a complete circle, it'll always be a diameter. If you're dealing with an arc, a half circle, that will be a radius. I don't know where this radius came from, but I think we could make it work. You know, it's like regardless of what we did in the past, like if you were designing a food right now, would you want a smaller radius, say 30, which is very rounded, or would you want a larger radius? Like if these were your feet and you wanted to be stable on the ground, would you want something flatter or something more round? I think, you know, like a bigger radius could be good. Yeah. There's something to be said about you don't want like a huge flat surface either. Especially if you're walking on a bumpy ground, right? It's like you could see how you want something that would kind of like adapt to the ground. So there's an in-between for sure. I mean, last time around we printed this radius. And it seems to have worked okay. Like I think it's kind of small, if anything. Kind of small, but I can see it working. And then you have our current food, which actually it's actually also nice, right? The new one looks kind of like a shoe. It's a shoe shaped. All right, so we're gonna build them from this line here. Coincidence. Pretty sure it should be coincidence. Coincident. Nice. Also coincident points. Okay, and then we can cut this like that. And then on this side, coincident here. Where's the cut? Do we actually need this point? I mean, to define the circle, sure. But, construction, this should be a construction line. Okay, so this angle is important. Alright, so kind of like depends what this angle is driving, so 45, so we can do 45 here, just match it, roughly. The other one's not perfectly 45. So then we end up with something like that. We don't need to edit in context anymore. We can just extrude these all the way to here. Something like that. Of course, we still need to blend this in and stuff, but I also want to point out here that if you see here, this sketch has a context reference here, because we built this in reference to the assembly, right? So actually, I don't know what part of the I guess we referenced the food here. This one here. So I'm gonna delete that. I'm just gonna hard code these to hard code it to here somehow. Yeah, just I would rather not have something with an external reference, because we will eventually delete that food from the assembly and something might break. Okay, so now we gotta blend this in. It's obvious what needs to be removed. That's not what I had in mind. Maybe it wasn't so obvious. I think last time it was actually pretty easy. I don't know why this time I'm struggling. Let's try that. Nope. Kind of weird geometries there. Actually, even here it's kind of weird. What's going on here? Oh, I see what's going on here. We have mirrored parts. There's two parts here. Alright, so let's make sure we're only working on the right side, and then we'll do the left side after. Maybe this will make things. Maybe that's why it was being a little weird. Yep. I don't know. We could remove that. could remove. I guess we can't remove that, but we could remove this chamfer all over and then re-chamfer again after. That's one way of doing this. I don't know if there's a cleaner way. Right, something like that. Yeah. And then we can do the same thing here. One operation, I think. Alright, so now our leg is nice and squared. And so, first of all, yeah, we can add a fillet here. Round it up, not there. Yeah, I'm kind of uncomfortable here. Here, not there. It always picks the wrong edge, like that's funny. It's not a 10. It's a 5? It's a 5. Something like that. A part of me still feels like it's too small. What if we just completely ignore what we had before and just make it bigger? Man, it takes forever to go back to assembly. Don't need this anymore, don't need this, don't need this. Part reduction, that's good. It makes Elon happy. Okay, so something like that. So we just became, we're now a little taller, I guess. Have you guys seen the Boston Dynamics robot, its feet? I think those look kind of interesting, huh? Has this like kind of like arch in here. Kind of like some organic shapes. This is, I think this won't actually matter too much, but you know, goes back to building something nice. Something that looks friendly. I'm also very tempted to try to put a shoe in here. Right, so if we put something like here, no, what would be equivalent? This ball's obvious. Something like this here. No. Yeah, I think this can't be straight. Something like that. Just making this up, guys, as we go. Just trying things. I don't think that's achieving the same organic feel as the Boston Dynamics one, just because it's too small, you know. We could leave this for now, but I don't think it's achieving the same effect. If you go down here. We could also try pushing it and just make everything thinner. And then round things more. Now this looks a little fragile. I'm down. I'm down to try that. Doesn't work as well with the chamfer. But yeah, I think that could be okay. It's in the name of reducing one part, right? The food and that heated insert also. It's for a good cause. It's not just us having fun here. All right. So the new food is there. Oh, it will be upsetting if this leads to some issues. The other thing I was thinking is like, now that we have this surface here, I can put something like some rubber thing, some material that increases traction there. Because I could try doing like a plastic pattern as we had before, but that didn't really work at all. Yeah. All right. This means tighten holes. All right. The other thing. Okay. Next thing. What should we do next? Knee offset. We could. Next, we can try to remove the this retaining ring. And if I remember it correctly, we basically. How did we do this? Let me double check. I think we just built in the retaining ring into the cam here. Like pretty straightforward. Oh, okay, I see what's going on. So we might not be able to consolidate the hip servo with the upper, because it worked here because it was one part, and we didn't have to care for how it assembles. But obviously it would be impossible to assemble this blue part in the middle of this gray part. We can still, of course, consolidate the retaining ring with the cam. That doesn't hurt. And let's take note of some of these dimensions. Don't say it with upper. Yeah, I don't think that's possible, man. Skip. Okay, so diameter clearance is 25.250 minus 24.850, and of course you have to divide by 2 because that's diameter, so that counts for both sides. And the axial clearance, so this here, axial clearance is 0.1 on, I assume it's symmetrical both sides. Yeah, cool. That'll be easy. So we jump back onto our leg assembly here. The new food is already growing in me. All right, so we want to remove this guy here. Actually, just, I mean, pretty sure that's the one, but let me just, I want to see how, so let me super sure here that, okay. Yes. Okay. All right, so I want to make sure I have this distance here. 0.55 top lip. And flash bottom lip. So my notes mean, because we're going to be modifying these group parts, so I want to know where this surface is with regards to this surface, because that's the key part, right? So that's the interfacing surface. And then the same thing are at the bottom. The bottom's easy because it's just flush. This one and this one are on the same plane. But yeah, that makes sense. All right. And so here we can hide these, and I want to remove these for now, or like once and for all. And so we go back to the servo cam. I think this might be the first time we're modifying servo cams. This is just one file having the left and the right servo cams, so don't get scared. We're starting with the right servo cams. I'm gonna name these things correctly, so there's no future. I do RHS, right hand side, LHS, left hand side. Because you could argue that just right or just left, it's, you know, could be confusing sometimes. Okay, so now that we have these, you want to find the right plane and the right axis to. Luckily, looks like these the planes are on the correct axis here, and so we can do a sketch, section view on this plane here, and I mean, this is as easy as it gets, really. Now you only want to do one. You only need to do one side here, because we're gonna revolve these all around. Revolve it around an axis. I was like, oh, this is the easiest thing. Turns out it's maybe not as easy. I don't know why it doesn't want to. Is it just the section views screwing things up? Not really. While we're in there, I think I noticed we need to clean up a few things before. There might be a radius here? No, there's no radius. I want to go back to the assembly here, and then I want to bring back this part here to use as context. All right, so we have our sketch here. I don't see our sketch anymore, but I suppose it's in there somewhere. Yeah, sketch kind of disappeared. Interesting. All right, so this will come like this, like this, like this, like this, and this will blend in here. right? And so we all understand. Oh, why can I reference components of my on the section view? That's really odd. What's the point of a section view if you can't use it like that? I mean, another way of doing this is just to measure things, but I mean, that's kind of lame. Okay, interestingly, this one did join there somewhere to something. It's like, is it bugging? Is this normal? What if I don't edit in context? Does it get better? It's kind of working, but I mean, that's pretty lame. I mean, I must be doing something wrong, right? Like, it's pretty lame. All right. Anyways, I'm just gonna measure. This is gonna feel very inefficient. It's because it is very inefficient. Dimensions. Okay, so again, whenever I do something inefficient in CAD, I just remember, oh, people used to actually draw on paper, and then I don't feel bad anymore. 4.6. All right, here we go. There's like this blue. Oh, it's not fully defined. Let's see. I was gonna say, I don't know what the blue symbol means. It means it's not fully defined. This just, all of this just solidifies my hate of on-shape, of course. Just believe it's not a serious CAD product. And the second we can afford it, we will switch to a better alternative. SolidWorks. If you work at SolidWorks and you're hearing this, like, reach out. 0.65. Okay. $24.85 divided by 2 plus 0.1. Man, that's annoying. Okay, so I've never had to do this before. This is outrageous. Tia would never. Anyways, that should be what we need. We can revolve now, so we can add this part, revolving axis. So this will be a interesting one to see if we should be able to use this feature as a revolving axis, and the merge scope should be this part, and so that should be basically that. It's what we need. And so if we go back to our assembly now, of course we did close that, so we have to like go out here and do a million clicks because on shape. But if we do a section view here, actually that might not even work because we're still in an old version of the file because you know, on shape. But if we create a new version, all right. I mean, it's basically that. It looks very, very tight. But again, it worked when we reprinted it as one piece. It looks very, very, very tight. Anyways, that's basically, those are the same clearances that that worked on the previous part. So we've removed just yet another part, so that's 2 parts off the leg assembly. Yeah. Cool. I guess the last thing I'm going to do here is I just want to change the color of parts because it's getting confusing. I remember we used to paint things green, and that meant we have reprinted them. But now it's getting confusing. So we're going to go with orange. Peach. Peach. Alright. A lot of orange in here now. So now if we do cross-section view, yeah, I mean, it still looks tight, but this you kind of want the joint to be as tight as possible, right? Like you don't want it to be a super high friction joint, but you also do not want any play on these joints. All right, what's next here? We're really flying here. I know we added knee horn offset. I'm not entirely sure that we actually need that. We haven't had that in real, like, oh, actually we might need it. Okay, so we definitely need it. It's more of a question of like by how much. I guess, okay, it's kind of hard to tell. By the way, every time I pick this up, this thing is so cool. Anyways, the knee horn, that's an easy one, so we can do that. For that, I think I'm gonna copy what we had on the monoleg. I don't know for a fact that that works, but that was based off a previous assembly that we had with nuts, and that's kind of like my best guess right now. 2406. We're obviously gonna round that up. All right, so let's go. All right. By the way, I was wondering, how can we make this look cooler? I don't know if anything comes to mind here. It is a huge chunk of plastic for no particular reason, in a way. But you know, it's my chunk of plastic, and it works right now. So yeah, like in theory, we don't need, like, this could be just like a straight line like that, right? In theory, I think that would also work. It's not like this is optimized for anything at the moment. We would save some plastic. That'll be the win. Now, doing this is a loss because we used to print on this face here, so it was nice and smooth. And if to do that now, we're gonna have to use support, which is not as nice, not as smooth. All right, here we go. We said 2.4, we're rounding that up from something else, and that's it. And so now we can go to the assembly, and now we have that. Now on CAD, it shows us we still have things flying. Now we could make things work perfectly on CAD and just hope that translates to real life. There's a couple of ways of doing this, right? So we could keep increasing this offset, or we could bring this down also. Actually, yeah, why do we have an offset? Why don't we just bring this down? How large is this offset? 4 millimeters, and this part total is 6 millimeter. And so if we're gonna thread in here, that's gonna be very thin. So maybe that's a reason why not to do that. This one we need to make thicker. All right, 1.6 more. .434 math. Yeah, math. Starts to look a little funky. Looks funny. I don't think I like that. Anyways, in theory that takes care of that. It does feel wrong though, but we'll see how it assembles. This is such a small part that if it doesn't assemble great, we can always print it on the, change it on the fly. It'll probably take 5 minutes to print a new one. And since we're fixing offsets, we might as well address this guy here. Basically, it's another change to the cam, and we just need to increase that by 2.5, which is, 2 clicks. So we do the move face command here, and 2.5. That didn't work. It's because we have chamfer, I think. And that didn't work. Yeah, I think it's not working because it's interfering with this chamfer here. Because if we do like something shorter, like 1, it'll work. But the minute you interfere with the chamfer, it doesn't work. So I'm gonna roll these up for a sec, and then I'm gonna remove this chamfer. I mean, we'll bring it back. Don't get me wrong. We'll bring it back, but I just need this to work for now. All right, and then we can move this back. All right, everyone's happy. Of course, this offset's kind of silly now, but everyone is happy. That's what matters. Alright, we can reintroduce this chamfer. I mean, something like that. If you're thinking it looks weird, I agree. I would agree with that. But now we have no offsets, which should help overall make a healthier leg. While we're doing that, well, knee horn offset, other cam offsets, unnecessary knee hole. So I'm talking about this hole here. We actually do not need a through hole anymore. and that's true for these also in the upper. So getting rid of this hole means, actually I don't know this for a fact, maybe it doesn't influence that much, but I think it will also mean we need less support, possibly, maybe not for that one specifically, but so eliminate, so all this stuff, if we don't need it we eliminate it. Those are the rules, of course. We eliminate waste. All right, nice. And now the leg will also look a little more streamlined from the outside. Now we do want to make sure that the fits are good, right? So last time we had interference, and that just comes down to some of the mates that we have. So we should fix these mates. I don't know what's causing it. Oh, okay, I actually do know. This is gonna be from a planar mate. We just need to find the right one. The section B seems to be messing up with some planar mates here. It's because there is no mid-plane mate in on shape. So I was doing a planar mate with an offset, and I must have calculated that wrong. But it's still on shape faults, guys. It's not like it's my fault. Come on. Can't blame me for this. Alright. Looks like some other mates broke. It's gonna remove every broken mate and then we'll reassess what's broken and fix it right now. Because easier to fix them right now. Alright. Alright, that's still completely off. Oh, I see what the issue is. 0.25. That's it. That will be centered. Perfect. Alright, now these appears to have broken as well. The cam appears to be moving freely, so we need another cylindrical mate here, here, and here, and that should fix things. Okay. All right, so also fix that. Perfect. Just so you guys know, this is the hardest one. Make hard stops to obvious and servo friendly. That's the hardest part. Requires thinking, leaving that for the end. Getting some easy wins here. Remove need for heated inserts. That's the last thing we have before we have to do big brain stuff. By the way, I was thinking of calling the audience big brain people. Big brains. Big brains. If you're watching these videos, probably big brain. Tremendous brain. Biggest brain we've seen. So these holes here are 3.8 millimeters, right? So, and these are M3 holes. So these are not meant to, for an M3 to thread onto. These are meant for, these are meant for a heated insert to go into those holes. But we don't want heated inserts anymore. So we actually want things to thread onto these holes. So in order to remove the heated inserts, we need to make these, instead of 3.8, maybe 3, maybe 2.8. I'll do 2.8, just extra tightness, but yeah. So we're gonna move the face. This is gonna take 1 second, basically. Move face 0.5, you know. All right, and boom, it's a 2.8, easy. Kind of like same thing here, I think. Yes. So we have 3.8 and we have 3.8. So we come here, move face, and yeah, heated inserts were kind of cool. You know, it just gets real. It gets old fast. You know, like unless there's a good reason you need them. Just adds more assembly steps, and I need to heat up an iron, a soldering iron, and like that thing is hot, man. Like it's like too hot. All right, perfect. All right, so we've burned down through our list here, a little too long, too fast. How am I supposed to make an 8-hour video if we're doing things too fast here? But okay, so let's think of the last step, right? So the last step. Wait, the heap's always at the top. You're right. Like it's being funny. All right, so so the servo, both servos have 180 degrees of motion. Degrees of freedom. Degrees 280 range of motion. So this could be our 0, and it could keep rotating. And that could be, you know, that would be 180, and that's just too much, right? We don't need that much, but that doesn't matter, right? So 180, that we can set this is our 0, and so if this was our 0, let me fix it here. First of all, would the knee ever be happy? Yeah, the knee could be happy. If this was our 0, we need a way to position these with respect to, you know, what's the best surface to measure 0 degrees from? You know, we want a nice flat surface that's predictable, right? So obviously, this comes to mind, this top of shoulder joint. So we want a way to measure, to position these, basically these 4 holes with regards to these. And I think, you know, the most obvious way, like one way of doing this is to add a new part, maybe a 3D printed part that adds as a jig that we use during the assembly process. That's one way of doing this. But what if we don't have to add any part? What if we don't need another part? Because once you have a part, a jig to use during the assembly process, you know, anyone who's building this, like, they'll probably have to read the instructions and understand how to use it. And it's like, oh, why do I have a part that doesn't go on the robot and all these things? What if I lose it? Oh, do I need a different assembly jig for each leg, each side, and so on? Ideally, we have some feature that's built onto the leg itself that helps you position things. So one way of doing this is, you know, if we're saying this is 0, the angle will never be negative, right? It will never go the other way, actually. Like, it will never want to do these, right? Because why would it? At least we're not designing for that. I cannot think of a reason why we would want the upper to go that way. Yeah, no, dogs don't do that in real life. So we could add a feature from this shoulder joint that kind of like blocks this from going up. Of course, that's not ideal because we're already printing this guy, I think. Or we have already printed that guy. But it could be one way of doing it. What's another way of doing that? Same thing. We basically cannot use the cam because the cam can move at any point, basically. Also, the only screws, these 4 screws don't matter as much as this one screw. This is the key screw that goes in because that's how we connect to the servo horn. These other 4 screws only connect these to the servo horn. But this screw connects the actual servo horn to the servo. So that's what actually defines the angle. So maybe we do have to add another part assembly, like another part to help us assemble. And we could use these 4 holes as reference. Definitely one way of doing it. Hold on, I'm gonna get a cup of coffee. All right, I'm back. No coffee, just 7-Up. All right, so I think it's gonna be okay to have some sort of assembly jig for these. Again, not my favorite solution. But it's going to, oh, that broke everything. Not my favorite solution, but I think it's gonna be okay. I do think a cleaner solution would be something that it's like built onto the part. We are not adding any complexity to manufacturing. All right, so if we assume 0 is parallel to this stop, let's now think of the knee actuator. All right, so again, 180 degrees. Probably somewhere there. Well, actually, I think for some positions it wants to go even past that. And then somewhere down here. Yeah, I think the knee for some positions can go higher here. Like for example, there. We'll never go higher than that though. So if we go back, so yeah, so that's not like the best position to get a good knee angle on this side without destroying the leg. On this side, however, maybe also not. So for the knee, we can go to the halfway point of range, that range of motion, somewhere like there. And that would be like, you know, if the knee actuator has a 180 degrees of motion, we can place it at 90 on installation. And so our jig would what our jig would have to do would be to hold these two things basically flat with respect to these things, right? So, and not block the holes where the screw needs to go. So yeah. We could even hold it like that, just for simplicity. Okay, I'm gonna get started. I'm gonna try to make, you know, what's the minimum viable geometry, and it might look a little funny, so don't look at me weird. It's gonna be like an experiment. Yeah. All right. I'm gonna create a new part on a different file. And I guess a new document. It's gonna call manufacturing assembly tools. And the part studio, it's going to be rear right leg, and that's what I have. So now we go back. Looks like someone deleted content from my file. I didn't know people could delete. Anyways, now in this file we're gonna add this new part that we created. Other documents. There should be a assembly tools. No part studios available. Assembly 1. Okay, I don't know what happened there. Is it because there's no, like, there's a part with no solids? Is that why? So if I make these like this. Let's try it again. Not entirely sure. Part studios need to be inserted from version documents. I have no idea what that means. I think that's a, oh my god. I think that's an unshaped thing. Anyways. Editing context. It feels very, very slow. Alright, so I'm gonna place this guy at that here at the top. And by the way, I do suspect we're gonna need a different one for each leg assembly, unfortunately. Without going super hardcore shape rotator in my head. Right, so basically sits here and extends all the way to the curvature of this part. This might completely backfire, by the way. Alright, so when I started these, I just created a random sketch. Let's actually constrain it this time around. We don't need all these planes. There's way too much stuff always happening on shape. Okay, well, to get a good mate, we do want to increase this area. And probably this area also. Right, so now we have more surface area in contact. I think we're gonna make these narrower so we doesn't interfere with these once we go down. But on that topic, let's also start going down. Or should we go down this way? You guys can see here, I'm basically, I imagine you can kind of tell what I'm doing here. Basically like creating this envelope around the servo, like the shoulder box. Yeah, something like that. So now we can go down here and also touch this surface here. Is that starting to make sense? It's okay if it makes no sense. Ideally it makes some sense, but if it doesn't make sense, that's fine. One of the hardest parts of a pretty hard part of making long videos is like people start texting you in the middle of them, and because I'm recording on my phone, I can't read anything, so I have no clue what they said, and it's like, oh, if it's important, I hope I don't know. I hope they leave a comment on YouTube. Anyways, okay, so something like that. And now you can kind of see here, we could, we're gonna borrow these surface here, which is nice and flat. We're gonna try to borrow. Could not select face. Never mind. How about now? All right, there and there. Yeah, just like that. And so we go here. I don't know why that broke anything. I don't know what's wrong with that being vertical. How does that break anything? I don't get it. What if I tell you this needs to be perpendicular? Breaks nothing, right? Yeah. Exactly. Alright, so something like that. It definitely needs to I was thinking something like that, right? So that horn can kind of like sit in there. So that's one thing, and then a similar thing for this one here, except we kind of have to, all we have to do is, it's the same thing, we just have to clear the we just have to clear the cam. Just be careful with clearing the cam, which is not hard. So yeah, it's actually pretty easy to clear the cam. So from here, we edit the sketch, and this is just the first pass. We also need to think of how this is constrained axially, so in the kind of like left to right direction in respect to the robot. So I'm gonna go here just to get it, just give it a little more space. and clear the cam. Clear the cam. A lot of clearance there. Yeah, and then we can remove all the stuff that we're not using here. I think these points, I don't know if these are real points. Can't select them, so ignore. There's gonna be a lot of references that it's okay. Like this kind of part, it's okay if it's full of references, since it's technically not a production part anyways. I'm okay with these not being as perfect. I don't know why that broke anything. Onshape seems to be very finicky with a lot of things. Alright, so 30 there. And we'll constrain these at 8 is solid from here for sure. And then we can remove stuff we're not using, so that. And these, okay, I don't know why removing that breaks everything. That shouldn't be the case. And then the other dimension here, we'll throw a 10 in there. All right. Yeah, now we want to go all the way out here. It's not extruding the entire thing. It's been a little weird. I wouldn't say that's missing face. It's been a little weird and not going all the way, but that's just on shape, you know. Can't complain. Gotta work with it. Alright, this is making no sense here. Let's try these instead. And it won't be fully defined, but let's just say it doesn't matter for this one. And yeah. I don't know why the second one's not working either. A lot of things not working here. All right, that should work. And so that's basically the first pass. Of course, we still need to constrain this on this direction, right? Because like right now it's basically lining up to this surface here, which is easy on CAD but hard in real life. And there's one easy way of doing that. So let me show you. But first, let's reduce this to 5. We don't need so much material. So probably something like that. And then here, this is how we would constrain it on the other dimension. We could do something like this here. I don't know why it's so laggy. Basically something like that. That'll be like the minimum viable geometry. And of course we could just close this face here just to make it a little smoother. This one. Oh, I thought it would be obvious how to close this, but apparently it's not on shape. I'm gonna point out the obvious here. Up to face. Something like that. Another obvious one would be this one here. Didn't work. I keep selecting up to next instead of up to face. So like that. And we can add some chamfers there or something. Actually, chamfers all around wouldn't hurt. Yeah, like that. Could probably fit one there. Here. Not like that. Here. And all around here. So I think these could kind of work. Then of course the next question is how do we print these without needing a lot of support? I don't think that's a huge deal. We could try it. We could start here. So this would be 0 for the servo and this would be 90 for the servo. And I think we would have to remap our servos from these new positions, especially the knee servo. And I mean, that's not a huge deal, but you know, it does take like a few minutes for sure. Yeah, so we can try that. Now, what we were trying to do was to also to make hard stops, but I don't think we actually need hard stops if we have good servo position control, right? So I would say leg hard stops. We've skipped these for now. Servo initializing tool. This is done. At least it's done for one side. Every leg would have a different one. Let me shave some material here also. The weight doesn't matter for these, but of course the material is not free. Yeah, we can definitely try these. All right, I'll print these with the along with the legs also, and update it. But basically, that's all I had for now until we can print the entire robot, which is in progress right now. I was also gonna mention, actually look at the new leg compared with the previous legs. I think it's good. I think it's a good move forward. Actually, that's it. Yeah, that's it. Yeah, so I'll get back when the entire robot is printed. Hey guys, I just wanted to show you these. Something happened in printing, and I guess Bambu didn't catch it. I didn't get an alert or anything. So this is what it looks like. So I was looking at the printer, it was making noises, but I didn't realize that the part didn't grow even though the nozzle was up there. The part was still flat, right? So basically, the new filament got stuck back here. And it's just been like there, so you cannot pull it. And so no filament was coming in. And I guess, you know, the printer doesn't have a way of sensing that somehow. A bit disappointed. I should have checked. It's just gonna set us back maybe like half a day or a day.
Eternity later.
Guys, it finally happened. We have all the parts. The new robot, old robot. I try to teach him to sit. Yeah, so we have the new parts on the new Miami blue color. Looks really good. Very excited to put this together. It took roughly 2 days to print. So we started printing on Friday. I was gone on the weekend. Monday, we had a print fail. No, actually, we started printing on Monday, Tuesday. And it finished Tuesday it finished overnight. So it is now Wednesday. And so like 2 days basically. And of course, I only have one printer. I was actually kind of hoping I had two. We could get these done faster. But yeah, I'm a bit hesitant about printing the entire robot again. It does take a while. Yeah. Also, this guy is like sitting here right now, but one of the issues is like when the robot is off, the servos hold no torque. So it always wants to just like fall to the ground. So anyways, first step, I have some tools here. First step is going to be to remove the support. We do have a lot of support. I used to complain a lot about these. Now it's become part of the everyday. As long as we're printing with a Bambu SLS, you know, we're going to have support. As long as we're printing FDM, we're going to have support. One day maybe we can afford SLS and we can move away from these. Of course, that has its own complications, but I think at some point there was a Kickstarter of an SLS Hobby grade printer. I don't know where it went, but yeah, new servo horns. We had to add support here to have a standoff here, and it does look terrible. But hopefully the fit on the leg is going to be much better. Yeah, so I'm just going to sit down here for as long as it takes today. I just clear my entire calendar. And whatever it takes to, first of all, assemble these, and second of all, I want to cycle the servos just to make sure nothing is burning or anything like that. And yeah, the next step after that can be to the next step on the next video, we'll actually figure out how to walk. Haven't thought a lot about that yet. But I mean, how do you learn to walk? The same way you do anything else. You just try, right? Obviously, I think the first obvious step is to just try hard coding a walk and see if we can do that. And if we can, come up with a function to kind of keep replicating that walk step by step kind of thing. Something like that. The other thing I was going to say was last night I went to watch this movie called Wild Robot by DreamWorks. First of all, amazing animation, amazing graphics, really cool. Obviously it's an animated movie, so it's not meant to be like hyper realistic, but it almost in a sense looks better in reality. Anyways, in this movie there's this robot that ends up stranded on an island. This robot comes from like quote unquote what we would call the future. This place that's like very clean, very automated, everything's super efficient. And so it behaves like that kind of robot. It wants to optimize things, wants tasks, wants to be efficient. But it's on this island with animals that just don't do those things, right? That's not how animals operate. They're more like survival, need to eat and stuff like that. I'm not gonna spoil the movie, but I thought it was at some point there's this idea of like, you know, I'm a wild robot. And that's the title of the movie, like Wild Robot. As opposed to like, you know, a normal robot that's like efficient and controlled and all these things. And I thought that was interesting because first of all, I think that's kind of like what we're building here. I think this will be a wild robot. Another way of saying that might be a robot with personality. These supports came out much cleaner. So anyway, I thought that was cool. Obviously, if you like robots, you might enjoy that movie. It is animated though. It is meant for kids, I think. Yeah. The other thing is like if you like Portal, the games, you know Portal, that franchise from Valve. I'm pretty sure the character designers borrowed heavily from Portal, or they might have been the same people, because a lot of the robots look like robots from Portal. The color palettes and the shapes. All right, the support didn't come up as clean. Anyways, we could probably time lapse this. You know, we'll just skip to the end where things are ready to be assembled. All right, that was all the support. And first of all, a few thoughts. This front part here, same part, same geometry, same settings. One of them came really clean here, like really clean part. The other one got completely messed up here on the edges for, I don't know, no reason. So I need to reprint this right now. So I'm gonna start that right now while we keep going, because that's too dirty to assemble. The other thing was, yeah, there's way too much. I cannot tell if there's way too much support or if I'm lazy, but it feels like Bambu, like when you have through holes, right? Bambu puts support on both sides, and I feel like you only need it on one side. So maybe there's some settings there to be tweaked. There's definitely too much support, I would say. Now, on parts where I did remove support, right? So there were like cutouts here that had a chunk of support, and there's less support now. I'm very happy about it. I'm so glad you know, I made that decision. Way less support. There's lips here, like this one here, where was very little support, and so when it's a very fine feature, like a step, like a lip here, it's like a little step. The support comes out so dirty, and like the feature is so small that you kind of lose the feature. So I mean, we added this to remove the retaining ring, but this is so dirty that I don't know if it's gonna work. The legs have way too much support. Yeah, it's mostly because of the curvature, and I don't think we need that curvature. We can come up with something else that still looks nice and doesn't require as much support. But yeah, for now we're done. There's a lot of the new features that came out that are really nice. For example, these fingers here to hold the servo wires. Those look really good. Same with anything, all the stuff to mount the boards. Those look very, very nice. So yeah, I think if my job was to remove support all day, I would quit on the spot. Let me start the printer for this part. All right, that's printing. It's gonna take 1 hour, so we have plenty of time. By the way, did you guys notice the new camera angle? I'm trying to increase production quality here a little bit. I've also been having fun with the thumbnails. I don't know if you guys noticed. Not that the thumbnails matter that much, but I just thought it would be fun. So, yeah, maybe a little cringy the thumbnails, but you know, you gotta start somewhere. Iteration number 1 is always cringe. And it is interesting. This is gonna be our 8th video together, which is me and the big brains. And so, you know, of course I always say, oh, I don't care the views and all that stuff, but at some point you just do something so many times that you start to get better, you know, you get a little bit better at the camera angles, a little bit better at setting up, a little bit better at editing, a little bit better at thumbnails, a little bit better at lighting. All these things start adding up. And of course, it's only this beginning, right? I can't say like, oh, I've done a ton of videos. I really haven't. But I was very excited to see we've crossed 300 subscribers now. So the goal was 500 when we started. And anyways, now I'm gonna disassemble this guy. Dude, one thing that comes to mind is, I don't know, maybe I should probably keep the screws so we can reuse the screws here. I don't know, or we could just use new screws. I don't want to be in that situation where we ran out of screws like last time. And today I'm using this new screwdriver, electric screwdriver that I've been using for about a week now. It works so much better than our previous one, and it doesn't break. And I also found these bits that can fit into it. Because then once this comes with, don't fit with M3s, but these bits do, and they're a little long, so they can reach the cavities and stuff like that. So, anyways, I'm pretty happy with these. I hated the last one. If someone's interested, I'll put links in bio. But yeah, I'm just gonna start taking this guy apart. And I guess one of the things, as I take this apart, it's like, I don't know if I can call this last design a win or not. Like, I guess we got it standing and stuff like that. But it kind of took long, at least long in my perspective. So it took us what, like 5 videos? Wait, okay, this is number 9 or 8. This is number 9. 8 was the PVC one. Number 7 was redesigning. So on number 6, I guess it took us 6 videos, if that's correct, to get the robot together. And yeah, I want to move faster than that. All right. So I'm just gonna disconnect the servos. We have to redo all the connections anyways, and we're gonna do it in a much better way. So, what I thought was funny that it's like we are increasing the power capacity of of the bus bar and the cables for the battery and all this stuff, but the servos themselves, This looks like 26 gauge wires, so the servos themselves will be limited at some point. Like, we can continue increasing the capacity of our electrical system, but at some point it will be the servos themselves melting, which, also this looks so cool, So yeah, so I was thinking about that. I was just like, I'm not sure how much more we can push these. I guess we're gonna find out. And then the other thing that has been on my mind was, I think a lot of these screws can be replaced. I know I always say that, but with plastic pins. So we can 3D print pins that can just, basically replace the need for screws. One of the things that this new design is better on is mass reduction. And I'm going to show that to you. So I'm going to bring out a scale right now, and I'm going to show it to you. But so, in terms of mass reduction, one big thing we could do is to remove the pieces made out of steel, right, which are the screws, and replace it with plastic. Pretty obvious. The other thing was that I'm definitely time-lapsing through the boring parts of this video because it's just a lot of assembly stuff, but I'm still gonna post it, even though it's probably not entertaining and probably not informative. But I'm just trying to convey exactly how much effort, so you can see for yourself how much effort it takes to build one of these things. So when you're building one of these things, this is basically your process is gonna look very close to this. I mostly say that because I do feel bad when I'm doing removing support for half an hour. It does feel tedious. Alright, so this is the latest, this is the new iteration of this part, right? So You can see some of the changes. We added some through holes for the servos. And this part was 49 grams. This part is 44 grams. We shaved 5 grams, so not a big improvement there. Actually, it looks like we had already optimized these guys somewhat. This torso thing, you know, this was 81 grams, and the new one is 76 grams. Another 5 grams shaved there. And of course, then we added this guy, which is 112 grams. So, yeah. Anyways, let's keep going. Let's see what else. We also shaved a lot of weight, I think, on this guy, on this shoulder. Where's, oh. Like, always cool to see the leg. Whoa, always cool to see the leg. Look at all these screws we've removed so far. It's uncanny amount of screws. And like I was saying, this electric screwdriver with this attachment here will actually, it's deep enough to go into here, into the screw that's all the way down there, which is really nice. Those are flatheads, so we need a smaller bit. Alright, 2 servos. Now we have this guy here at an angle actually. That one's the hardest. I might need to go get an Allen key for this one. Let's see if this works. No chance this works, huh? No chance that works. I'm gonna get an actual Allen key. Alright, so this one's kind of annoying. And we still have the same issue in the new design actually. It's a screw that's hard to reach. Could be worse though. Okay. Alright. So this box here, right? So we got rid of the cutouts here that require a lot of support. So we put material where there was no material, so that should add mass. But then we also made all the walls thinner. And then we also got rid of some of the holes here. So let's see if we added mass or removed mass. So this guy, the old one, is 28 grams. And this guy, the new one, is 29 grams. So we added 1 gram to reduce a bunch of support, and I think it looks cleaner. But I'm surprised. I thought it might be lighter, but I guess it's not. All right, servo pile onto the next leg here. Dangers of working with a knife. All right, so isn't it crazy fast with the electric screwdriver compared to like, you know, when I had to, last time when I assembled the entire thing with an Allen key? That was painful. Now I feel like we're flying through it. Again, this thing looks so cool. Looks really cool. That's why I'm not taking it apart. It's too cool. I'm gonna get more coffee. I'll BRB. Alright, so this assembly has been so fast so far that I think we're gonna start assembling even before that new part is printed. Telling you, this guy is a game changer. Game changer. Today I had an interesting conversation. I was telling a friend that I was like, man, I think I could probably build like a robot suit, a set of suit. I was like, either it was something between Jurassic Park but they're robots, or Pokemon Land but the Pokemons are robots. You can't even tell. And he said, which is like, I think it's an interesting point. He was like, dude, just build AI sex robots. That's gonna sell better from day one. Product market fit from day one. And he's not wrong, right? It's probably true. And then I googled AI sex robots, and it turns out, yeah, there's people already doing that. The first click was from China, actually. Like, I was surprised. Just in terms of SEO, no one in America seems to have gone for AI sex robots yet. So that seems like a big opportunity. But then I started looking at the videos of this robot in China, and I'm like, that's probably not the future I want to build, you know? There's a few things, you know, if you feel ashamed of telling your friends what you're working on, that's it's probably not good. You can't tell your family what you're working on. And sure, I don't expect your parents to understand that you're working on a robot suit either, but at least it's not like, oh, I'm making robot prostitutes. Which if you are, I mean, things are illegal, so I'm not gonna stop you. Just saying, like, it's probably not my thing. I do think that it's very easy to go down that route of like making life so easy through technology with things like, you know, quick and easy dopamine basically, which is, I think AI robots helps. But is that really like the reality that we want? That's also why I'm not a huge proponent of VR, because I'm like, you know, it's like, I think we should spend more time making the actual reality better than kind of like escaping to a virtual reality that I have no doubt can be made infinitely better with less effort. But and this is probably gonna be like this is not gonna age well, but you know, I just think like the actual reality is, you know, what we should be focused on. That's who we really are. Even though like everything points that, oh, you know, virtual reality is a feature, and you know, you're gonna have virtual friends and work remote, and you don't have to go outside, order food. You have robots at home that clean for you, do everything for you. It's like, what are we gonna do? Is that really what we want? I'm also not a big proponent of like self-driving cars, actually. I mean, I do like these stats, right? It's like, it's safer. How can you like not want safer? How can you not want less people to die, right? It's like, no one's arguing that, oh, more people should be dying out of accidents, but it's like, I do like driving, you know? It's like, I like driving my car. Sometimes at illegal speeds. All right, so we're ready to keep going. We could either start with legs or we could start with the torso. So if we start with the torso, I guess the first thing would be to basically get those ports here, right? So this is the Arduino Uno. I'm just gonna disconnect all the jumper wires. There's so many wires, that's crazy. And so, you know, the first step is you can basically grab these and the holes line up on the board, and like you can just screw it on, and you can access the USB from the outside, which is one of the new changes we've made. Very cool, you know, it's very nice. I approve. Let's see how well the fit goes. I'm gonna use flat heads for these. That's very nice. All right, we broke one of the standoffs there. I think the holes might be too tight for M3s. We don't want to break any more, so I'm gonna try to find the calipers. Found the calipers. Maybe those are more like M2 holes. It's too big for M2. Maybe we go slower. This guy's stuck now. Basically, as I was going in, the plastic just sheared off. Maybe this is too powerful for these. Alright, Alright, so that sucks. We have one more chance. We can't screw this up. I'm gonna try to go in manually. Just manual sometimes gives you a better feel of what's going on. Alright. If we break these, I see the issue. So the holes are not deep enough for our screws, and so they reach the bottom and then they break. I don't know if I have any shorter screws here around. Let me see what we have. These are already pretty short. Normally I hate having like small screws, you know. The shortest one are 6mm. Okay, they are shorter. Normally I hate shorters, but by the way, I think the next improvement when we reach 500 subs is gonna be to improve the audio. Get a microphone. Because right now I'm talking and I don't even know where the microphone that camera is. That camera meaning my iPhone. And then I walk away. I keep talking to it, and it's like I'm sure. Oh wait. I should have checked if this was gonna be deep enough. It should be just deep enough. Not as to not to break. Okay, well it didn't go in all the way, but I made it a low resistance, so I'm not gonna push it. I already broke 2. So I guess a future iteration we should either make these things longer, through holes, or get shorter screws, which we're not gonna do. Alright, now that that's in place, the next thing would be to get the electrical stuff. The back converter in there. For that we need a flathead. And well, now I know not to use long screws that will break stuff. Alright, this guy might be too powerful. Did I break my butt? This guy might be too powerful for some things. You can still use it manually though. I think I might have almost sheared off the buck converter connectors. This guy's very torquey. Alright, looks to be fine. Okay. And so the battery cables go down through this through hole here, right, like that. And then you just screw this down. They are bending quite a little bit, more than, you kind of like never want to bend wires too much. These are definitely bending. But I think it might be fine. And these are extra short screws here. I'm gonna put them in manually just to get a feel. Make sure we're not breaking things. We could also add washers to kind of like take up some of that space, but these came with no washers. Only nuts. So I don't really believe in washers, I'm joking. Believe in washers. It's already looking cleaner. Alright, here's another idea. Instead of making so many through holes, we can just have maybe like 2 through holes and the other ones should be pins. Because right now it's hard to locate these in place. Yeah, I'm not having fun. So maybe our CAD model was slightly off with the back converter. Actually, maybe we're fine. So this screw is being way more annoying than I thought. It's like it doesn't want to go in. And the wall is right here, so it's all very tight. Do we just go with 2? Okay. Alright, that finally went in. That was hard. Than expected. Not hard. Okay. That's our board. Much cleaner. I did mess up the Arduino thing a little bit, but everything else kind of works. So now, on the flip side, we have the bus bar here. Which we also need to do manually because it's too small. Guys, this is why I have electrical engineering friends. It's like, this electrical stuff is just not as fun. And what's funny is that they feel similarly about mechanical stuff. They're like, yeah, I can CAD, but like, I don't want to. Can you just CAD things for me? So these are the guys that melted. So these are not good to use anymore. And then everything else, I'm just gonna take apart. Just shedding wires here, shedding wires. So it's 28 wires total from this bus bar, which is, sounds like a lot, looks like a lot, feels like a lot. 28 wires means 28 screws that I need to untorque here. And you can probably hear the 3D printer in the background. It's that Wally kind of noise. Printing the last part we need. I also found a hot glue gun in case anything else breaks. Instead of 3D printing for another 2 days, which I'm out of patience for, we just hot glue things. That's how we roll. All right. So now this guy, we can put down here, kind of like that. So battery on this side, bus bar on this side. And that's really everything that's down there. There's nothing else. So, see that? We use the same small screws. All the stand-ups for the electrical stuff are the same size, so if we already broke a couple, we know that everything else is at risk of breaking also. And also they don't like going in, so it's like we might need to make the hole slightly bigger. I'm gonna use the electrical screwdriver here because see if this helps. I am glad we made the opening as big as possible here, because it's always a pain when you have to work in an enclosed space like this. Went in right away with the electrical screwdriver. So I get it started with the electrical, and then I'm gonna finish it just manually, again, just to get a feel for it. I don't want anything else to break. This one only has 2 screws, so if we lose one, it's GG. Alright, I think that's as far as they go, and I can see some play. We'll be fine with the play, but yeah, something to do. And then the way these two marry, quote unquote marry, engineering work, it's through some screws on the outside. So it'll look like these. And so we can do this right now, I think. I haven't fully thought of like the ideal assembly procedure for this stuff, but I don't see why not right now. Doing the wiring later, we do have to crimp connectors and so on. That's gonna be, first of all, first time we do that. Also, I was gonna say that's gonna be fun, but in a sarcastic way. I wish this was magnetic, so it would stay when going upside down. Alright, so basically these, right? So now we have the torso with the electronic components. Yeah, now these 2 wires that are already in place are to power the Arduino, so we can just route them through here. And it's 5B and ground. Right, and so now we just gotta do a bunch more for everything else. Oh, actually, yeah, we can also put the switch here. We can see how the switch fits. So here are the switches. I never knew with these guys which one's on and off, honestly. Dash or O means nothing to me. Some more support there that made it all the way to now. And the way this works, in theory, you could just push it inside. And I'm trying to decide if it's a good idea to do it now. Anyways, you can just push it. And there it is, right? So now we have a switch. It's overall much cleaner package, right? USB here, cable wiring. Like, yeah, I think this is it's a pretty okay effort. All right, so before, don't do too many wires for now. So next we're gonna assemble the leg. Because I don't want to deal with, look at this mess, look at all these wires. Don't want to deal with that right now. We will have to deal with that today, but maybe after lunch. I don't know what time it is. I don't know, what time is it? Oh, it's only 1. All right, let's drink a Sprite. I actually have no clue how long we've been sitting here for. Maybe like an hour, 2 hours. All right, so as is tradition, we always start assembling the rear right leg, which should look like this green leg. That was the first leg we ever built. And let's go. Look at the new feet. Yeah, right? I think it's nice. This leg actually looks much better. We printed it in a different direction. We're not printing like this. Yeah, we should have learned from that. There's better ways of slicing these. Anyways, so it looks like that. One of these, agnostic to whether it's left or right, front or rear. You can just pop it in. No! This is bad. Oh my god. Alright, maybe a little hard to just pop it in. Let's try one. We have one more shot. You're supposed to just be able to like pop it in like that. I guess it's not, it's a little tight, but it'll work like that. You gotta be careful, I guess. Yeah, I guess we're pushing it. That sucks. Then you choose one of these things. I forgot to write left or right on these guys, but this is the one we want. I'm just copying the leg we already have. Man, that really sucks. I'm gonna have to print that. That's probably like a half an hour print. Oh, should be more careful. Anyways, show goes on. We have so many things to assemble today that I'm sure we can wait for the print and still not be done assembling. Super easy. No metal inserts like the one before, right? So much easier. Yeah, it's really all it is. Like so easy. So now we replicate the same thing for the other legs, and we try not to break anything else. We really try hard not to break anything else. Oh man, okay, here we go. Here we go. Nothing broke. Easy as pie. Oh, nothing broke. So I guess it's defective, or I went crazy on it. Anyways, you live and you learn, or something like that. Live, life, learn. Live, love, love. Live, life, love, and learn. We added a new word. All right. This is honestly so much easier than last time. All because of the electric screwdriver. Well, and we also made changes to the leg that, you know, make it easier to assemble. The fact that we don't need heater inserts anymore, it's like, that was the whole thing, man. So the leg looks like. I really hate the look of the surface when you remove the support. Not good. Something needs to be done about that. We will eventually do something about that. I don't know if I've talked about this, but eventually I want to wrap these and give it a fur. I don't have a sewing machine, but I do have a girlfriend, and she said she can do it. We'll see. I could stack these legs all day. This is so easy. Alright, and even though I did break one of the legs, we can still assemble every other part of that leg. And then come back to the part I broke. So sorry for hurting you. It was also a rear right, which is our favorite leg, guys. I guess we'll have to use the green leg again, you know? We'll just keep using that. We can't get rid of the green leg. Oh my god. I'm gonna have to add a magnet to this screwdriver. It's very annoying when going against gravity. Alright, so this leg is ready, just missing the part that I broke. But if it wasn't for that, we'll be ready. Now the reason why I wanted to start with the rear right is because we also made this jig here that basically sits on the, and it's made around the rear right, so it sits on here like that, and it tells you where the servo horns need to touch. But I think this will only work on the rear right. Using my big brain to try to figure out, but I'm pretty sure it's basically only works in the rear. Yeah, which is very unfortunate. Because you know what that means, right? We're gonna just have to eye out all our other stuff. And so now that we have these legs here, we have that quasi-assembled, we could either start with the legs, and so we have to initialize the servos and do all that thing, or we could start with the wiring. Now I think the wiring will make more sense once the servos are in here, so we know what goes to where. Yeah, right? I think that makes more sense. What do you guys think? We also have to wire the switch. So for the switch, basically we have a high voltage and a low voltage. Like before the back converter, out the battery, that's higher voltage. After the back converter, that's low voltage 5V. Before the back converter, it's 24V. I think the switch should go on the 24V side, because, and this is like an approximation, but you know, if power equals current times voltage, higher voltage means lower current, so lower current flowing through our switch, it's not gonna melt. Whereas if you do it lower after higher voltage, more current, it might melt. And that switch can handle the current anyways, so yeah. Anyways, what I'm gonna do is I'm gonna start assembling the servos. Because you know, first we have to screw all the servos in here, and that's very, you know, it's a very obvious step. And after, I mean, the replacement bracket for this guy is almost done printing. It says, oh, actually another half an hour. After that, I can start the replacement legs for this guy. But we should be able to, you know, have everything done. Even though we cannot, you know, even though if we don't have jigs for everything, I'll just initialize by eye. Seems to be working okay so far. Really, what we need to risk here is the fact that, you know, can we actually run all the actuators at the same time without absolutely melting our power board like last time. I might have underestimated how fast this assembly is gonna go with this electric screwdriver. This might be the shortest video we make today. I'm joking, but it is going. This is mixing so fast. It's so much torque that it starts. The parts like start spinning in your hands, and it does have multiple torque settings. So by rotating here, there's a 1, a 2, and a 3. I'm at the lowest. There's more torque if you want it. I did use one of these things to assemble like my bed frame once, and it works great. But it's that amount of torque, like bed frame torque. Not like screws into plastic torque. Oh, I just thought of something. The reason why you don't want to assemble these servos first, oh actually we might be fine. Usually you don't want to assemble these servos first because then you cannot reach the screw to put in the servo here. But I think we're fine. I had a little heart attack there for a second. I hate when I do a lot of things and then I have to like go back and redo it just because I missed some step. Looks like my good design has saved us this time. Of course, that was highly intentional. I made sure it was possible. Okay, this servo doesn't want to fit. I wonder if it's a servo thing. Not all servos are the same size. Not all servos are created equal. Apparently not. These servos slightly bigger. Tolerances and stuff. Alright, we are missing one screw. I'm gonna go find the screw box. Alright, so here is the screws. Just need one more. I think we used that screw on the Arduino. Yeah, the Arduino board, and that's what's missing here. It's just like a black end. Such a game changer. I love this. Alright. So those are our servos. So next step is the shoulder servo. So we do need to initialize. Before we do that, I'm gonna go to the bathroom. I'm gonna pour more coffee, and I'll be back. All right, we're back. So now we're gonna initialize the servos, and I'm gonna flex my brain a little bit here. Tremendous brain, right? Remember how I was talking about how I got an extra Arduino? There's the OG Arduino, there's the new Arduino, a separate Arduino just to initialize things, so we don't have to touch that one, we don't have to power that one, all that stuff. Second big brain moment, USB extension cable. You know how in previous videos, the cable has gotten on the way, always my computer is about to crash to the floor and stuff like that. No more. Now we have long cable. Tremendous improvement. Simple improvement. $10 improvement. Tremendous $10. Tremendous leverage generated by $10. This is what they call creating shareholder value out of thin air. You give me $10, I give you tremendous productivity improvement. Just unbeaten. Alright. Using this for the first time, I think it'll work. It's like a pretty long cable. I think it'll work. When you work with USB-C cables, they're a little bit finicky. There's like multiple kinds of USB-Cs actually. Some are meant for data transferring, and some are just power. But this is plain old USB 2, and I think it's fine. I don't think there's gonna be any issues. I also got some more jumper wires. And so the strategy here is to basically build us a small jig, quote unquote, or like something like a small thing that we can continuously use to initialize any servo. And so we're gonna write firmware here once to always be setting servos to 90 degrees, and then we can close the computer. We don't need it anymore. I'm joking, we actually need it for power, but other than the power, we don't need it anymore. So I'm just setting up here the usual stuff, you know, red to 5B, brown to ground, and then PWM to pin 10, or any pin you want. I just do 10. And now in theory, oh my god. Oh, I also sliced one of these new parts. It takes like 45 minutes to print one. So that sucks for me, but I was planning to fully be here all day anyways, so I'm not going anywhere. Alright, so connecting this servo here. Honestly, oh, it's very tight. Allow accessory to connect. I would like show you my screen as like what the code looks like, but this code is very simple. And basically all I'm doing is I'm going on ChatGPT and I'm telling it write an Arduino script that sets digital pin 10 to 90 degrees. It is a servo. Use servo library. And that's all I'm saying. And you know, ChatGPT writes like 4 lines of code. That's really all it takes. And then I basically upload it to this thing. It's done uploading. I close this. The cable is so long, computer can be on the ground. It's okay. Big brain. Then I grab my favorite the servo here, and I just connect it, and it will go to 90 degrees. Okay, I might have cheaped out too much with the jumper cables. Alright, 90 degrees. Now, that's it. These jumper cables don't really fit. Anyways, the only thing we could screw up here, we gotta be careful, is the position of the servo. Yeah. So this is from left, so this goes here. And so this servo goes like here, I think. Wait. Here. So we should let's position it like this. So it should be like 90 degrees, right? So it's like 90 degrees. Actually, yeah, 90 degrees would be like these, and then 0 and 180. And so all we have to do now is kind of like push it in. Doesn't want to be pushed in. I respect that. We're gonna start putting our screw here. All right, this is a little more difficult than I anticipated, but we will prevail because we always prevail. There it is, prevailing. we can actually start screwing it even before the servo pinion is in the plastic. Another big brain idea would be to make this a through hole, so I could put the tool through here and screw it this way. The only downside I see for that idea is like the slicer is gonna add crazy support. Maybe I just need a better slicer, you know? One that gives you more control over where to add support. Someone left a comment on one of the videos saying that the Ender slicer gives you a lot of more support, more control over where the support is placed. And I believe him. I want to try it. Anyways, that's it. This guy is now set, and now you can move. Yeah, this servo makes funny noises. Okay. Now we do this 4 more times. Of course, we've gained knowledge while doing the first one, so now we will be faster. And I'm just gonna use my same Arduino setup. Don't have to write any code, connect computer, no. So we've streamlined the process here. We've created enterprise value, shareholder value. We've accelerated. You know what? I never actually checked ChatGPT's code. I didn't read the code. Let's make sure it's 90 degrees. It is 90 degrees. Just trust ChatGPT, you know? Yeah, I wouldn't lie to you. Right RL, rear left. So this guy goes like here. And this guy goes like here. So like here, like this. Honestly, if I'm getting any of these wrong, I would be very surprised. So. All right, another one done. Next one. See, it really helps that for the shoulder, all the servos are initialized to the same angle. As we move down to the leg, unfortunately, this will not be as easy. But in that case, what we can do is we can set different pins to different angles, and so we don't have to be uploading new code to the Arduino. Just switch the pin. Instead of pin 10, just go to the next pin. That's big brain idea. Tremendous brain today, guys. Front right, FR, front right. This goes like here. All right. Front right. Last but not least. Rear right, the one I broke. Tough stuff. The next leg I print to replace the one I broke, I'm gonna slice it a bit different. So it's gonna use way less support. So at least there's that on the bright side, you know. It's like I realize I sliced things inefficiently. All right, now all the shoulders are good. So really the next step could be either mount them here or start putting the legs. So I think we can start putting the legs. I don't need to scale anymore, it's dirty. Okay, so to install the legs, we'll need 8 screws. So we have 1, okay, perfect, 8 right here. And it's a whole thing of like, oh, how do we initialize it, right? So what this guy was supposed to do for the rear ride right here is, you know, you kind of like, you put it like here, and yeah, first of all, tight fit there, perfect fit. 0 clearance on that actually, by the way. And then let's assume this is the rear ride. It isn't. You kind of put this here. And so this surface here tells you where this leg should be all the way here, and this one tells you where this horn should be. So all the way down here. And so this is 0 and this is 90. Something like that. I thought it was a good idea. I still think it's a good idea. Oh, we can use this as rear ride actually. It's the same leg. And we can use our jig. The one thing is like we do need the servo horns from this previous iteration, from the orange one. I didn't bring new servo horns because yes, they're orange, but they're in the all the way back, so you can't see them. So let me get those right now, real quick. That feels incorrectly long. It's like, what? How deep does the middle one go? Let's see. That's not deep enough. Alright, so it looks like we don't even have the right screws here. Anyways, I'll fix that in a little bit, but these are not the servo horn screws that we should use. I'm so glad we have the electrical screwdriver for these, because these are so long it'll take forever. Still kind of takes a little long. See, this is the part that we needed. I don't think we need this anymore, so I'm gonna put it on the bucket of scraps. Even though it has valuable screws. I guess, okay, not going to scraps yet. Oh, we're gonna have a green part. This servo horn is green. That's nice. Historic part. We don't use green parts anymore. That's nice. I'm glad a green part made it all the way through. Little souvenir. Actually, the 3D printer just finished printing this other part, so I'm gonna take that off. So we can start printing the leg. Right, so this is what it looks like. It's still kind of messed up the edges here, but at least now we have a hole. The previous one didn't even have a hole, but it's so dirty. I don't understand why it's messing it up. I'm gonna have to add well, okay, first of all, this is good enough. I'm not printing that again. That would be ridiculous. And let me just kick off the next print of the leg that I broke, the upper. And that will be another 46 minutes, I think. It says 50 minutes total time. Alright, so here we go. Of course, we're gonna have to remove the support of the part we just printed, but that's life. By the way, did you guys watch the Joker 2? The guy has like no wrist. It's like way to kill a character, you know? I thought it was gonna go somewhere, but they basically killed the character. It's like Joker's not cool anymore. If he ever was cool, I think some people would have sympathized with him. Probably not anymore. Alright. Even these old parts, actually they're not bad. This thing was decent. I think the holes on these horns are too loose. Because even as I'm screwing these things out, if I push them, they'll still go back inside. So, which tells me that the threads are not actually threading into anything. It's not a good sign. And like, they should be replaced. Alright. So with that out of the way, we can actually start assembling these into our existing legs. I'll keep the rear right green for historic purposes. Actually, let's see if this guy even wants to go in here. There's a lot of support leftovers. It's very dirty. It's very annoying because it's such a small feature. It kind of goes in. That's the printer, by the way. It's that noise it makes. It's cleaning its nozzle. Kind of crashes into a roller thing that cleans the nozzle. It's one way of doing it. Green part 6. I can already tell this didn't go in good. As in, like, this green part should be flush with this, but it's really not. And I think it's just because there's support material in there. And even now, there's a lot of friction. I guess if we move it a little bit, it'll start to crush that support material. I mean, where is it gonna go though? Friction is not good because it means our servos need to work harder. When our servos need to work harder, they pull more current. More current means things get hotter. We don't like doing that. So this is just one of the ways support is not good, you know? Trying to clean it up, but it's really hard because it's such a small feature. All of it is basically support. So I think this is like another thing to redesign at some point. Maybe we just bring back the retaining ring. Maybe that wasn't that bad. It was kind of working. Or maybe we print this different so the support marks are on the other side, which is not as critical, but it will look very ugly. What I don't want is more torque through my servos, because again, I'm already worried about things getting too hot, things melting again. But by the way, after the last video on PCBs, I got reached some inbound on a company that wants to offer us free PCBs, so that's good. All right, okay, see, high friction. We don't want friction, guys. No friction. We want smooth joints. Yeah, this is a little high friction. If we struggle with thermals on the electrical, this is probably where I'll get started. I mean, we could keep upsizing the wires, but reducing the friction on these joints will help decrease the torque load for sure. Alright, so that's that. So next step, we can actually assemble the legs. So we need to initialize the servos. For the right side, the hip goes to 0 and the knee to 90, and for the left side, the hip goes to 180 and the knee still to 90. So what I'm gonna do is I'm gonna tell ChatGPT now set pin 10 to 0 degrees, pin 11 to 180 degrees, and pin 12 to 90 degrees. Get it? So we can just switch the pins as needed. And the code is again very simple. It's like now it's 10 lines of code, and we just just copy paste, upload it. The key part here to remember is that pin 10 is 0 degrees, pin 11 is 180, and pin 12. So pin 12 is knee, pin 10 is the right side hip, pin 11 is the left side hip. All right, and so the other thing we need here is more wires. We don't need more wires. I'll just make this do. Okay, so rear right, rear right. This leg here. Oh, the friction! No friction, please. Okay, I can use my jig here, and I'm gonna set my hip here to 0 degrees using the pin 10. That must be 0 degrees. No real way to record. Oh, okay, stay. Seems to be stuff in the way. Very close to 0 degrees. Alright, so you see, this is exactly touching this, so that should be 0 degrees exactly. With that at 0, the knee can still move. It's It's a lot of friction, guys. Now the friction is mostly on the knee side. And so for the knee, we're gonna set it to 90 degrees. And so what did we say? Pin 10 is 0 degrees. Pin 11 is 180, and then pin 12 is 90 degrees. So we go to 90. We put our jig here, our jigger, and same thing here. This surface here needs to be flush with this one here. Okay, so something like that. Not sure what screw goes in here, but probably something like that. Let's try a slightly longer screw. So I think that was an 8mm, so I'm gonna go to 10mm. But other than that, that should work, right? All right. All right. So these legs should be fully assembled now and correctly initialized. Now the issue is that we only have this jig for the rear right, and we would need a separate one for the rear left, and so on. By the way, there's some play on these knee joints. There's some play here. We could tighten that up. Of course, if we tighten that up, we already broke one leg coming in, but I don't like play. And so these legs should be perfect. It should be the perfect leg. We cannot ask for a better specimen of a leg. And I think that worked pretty well. So I wonder, maybe we should just print these things for the other legs, right? And in the meantime, while that prints, we will. Well, actually, what's keeping it from using these on the other right? Let's see. Front right. Front right. I think we can use the same one on the other right also. Front right. Of course, we don't have another right leg because I did break it. For the most part, it seems to work. There's a little bit of interference with the feature here. We can shape that. And then really the only thing we need is to print one of these for the left side. And this part should probably take like 5 minutes to print. It's not. It's pretty fast. So maybe what's upon us right here is lunchtime. Maybe it's time to go for lunch and come back when the new leg is printed, when the replacement leg is printed, and we have our jigs. This is one of my favorite parts, putting these together. It just looks so cool. Yeah. Rear right. I really hope the friction's fine, but yeah, you like kind of. I'm getting deja vu, right? Because we've already been here. We basically already assembled this leg before. It was orange. All right, let's see if these holes to wire the servo wires actually do their job. That looks pretty good. Should be way tighter. It looks way tighter to me. I'm very excited. Yeah, I think basically the biggest improvement is with the electrical stuff. And so things are not gonna look like so messy anymore, which is good. It will look like an actual engineering project. Yeah. Anyways, I'm gonna go for lunch then, and I'm gonna print one of these for the left, so everything's gonna be perfect as it comes together. And then we'll pick this up. We'll come back in. We're getting close. All right, I'm back. We had lunch. We have the new leg. It's not broken anymore. I do not intend to break it. The new orientation where I printed it. So I printed it this way here. This way. So before we were printing it, I think this way or this way. So this was all full support, and there was support here. This way, when you print it this way, there's only support here and here, and so you can just ship it off like that. I guess these holes have support. Way better and way smoother, way nicer. I love this. I'm printing these for the left side now. I'm still disappointed at this part being destroyed here. Very disappointed. We could print it again and have support on those edges, but probably not worth it. So I'm just gonna remove support here real quick, and we'll have our last leg assembled. Hopefully I don't break anything. It's so easy to remove support here. Hopefully I don't break anything this time. I like never know. It's not on purpose, guys. Swatch them out. During lunch, I was listening to Tesla's earnings. I think it was their Q3 today. Stock is up a lot. They basically beat expectations. The Tesla energy stuff seems to be growing really quickly and accelerating. Still small compared to the car business, but it's finally taking off. It's pretty cool to see. And during the call, man, every time Elon talks about the robot Optimus, it just makes me so excited. I'm like, yes, they are probably gonna do it. They are probably the guys that are gonna win that space, or they're gonna have a very strong product. Elon talks about like how they're uniquely positioned because they have the capabilities to scale manufacturing and the brain, so they have the compute. But I also think the fact that they have so many factories, and they have demand for the product. So they're basically they will be their first big customer themselves. They'll serve themselves, internal customer. And I think that will help a lot with adoption. You can accelerate adoption much faster when it's your own robots, your own product, your own factory. You're going to be willing to take more risks. You're going to be more open-minded and things like that. So if you don't have Tesla stock yet, what are you doing? And I don't know. Probably a good stock to have. There's been like about 2 times in my life where I was all in Tesla, all in. Every stock I own in this world was Tesla. It's not the case right now, but I don't know. When I hear Elon talk about Optimus, I'm like, oh, maybe I should just not think too hard about this and just do it. Anyways, that's all the support. I like there's one more here. Something flew off. That's all the support. I'm really glad we're using different colors of filament because else it will be very hard to tell things apart. Alright, now I'm going to try to put this in again without breaking anything. Easy. Easy. I don't know. I don't know how I broke things last time. That was embarrassing. All right. I had a screw left for these, but I guess I used it somewhere else because I can't find it. So. Oh man, the friction here. Uncanny. I thought it was fused or something. If I have to bring back the retaining ring to minimize friction, I wouldn't be mad. If something blows up electrically, I would be mad about that. Alright, so we can continue with our same Arduino setup here. Just let me plug it into the computer for power. Computer can be folded. Okay, so what we said is we can use these for the ride, either front or rear. We already have the rear installed here, so we're gonna do front now. So this is the front, and we're looking for FR here. This is FR. And so it'll look like this. We put this here. There's a tiny bit of interference. I already fixed this for the left side, but we can still just make it work. And then you basically, all you have to do is you come here, you place it. Oh, whoa. Actually, first thing is you power this hip, this servo hip servo. And we said pin number 10 was for 0 on the hip, so that's 0. So now the hip is in the correct position. You have your jig here, and then all you have to do is line this up, just like that. Maybe just like that. Just like that. And now we put a screw here. I never know how long screws to use here. Just gonna try this one. Alright, so that should be good for that one. And then for the knee servo, we do 90 degrees. So we connect all of this stuff here. And then we said pin 12 is 90 degrees. And the same thing here, we line it up with our jig. We make sure this face here, the horn, is touching this one here. And I think that's basically it. Yeah. So this is the front right, so it's gonna go here somewhere. Well, now we gotta route our servo wires to the correct conduits. And I think the printer is finishing with the left side jig right now. It's perfect timing. And now we put these screws on. I'm still only using 2 screws per servo. It worked fine last time. Not that we moved a lot last time because we couldn't move, but maybe this time we'll see. We can always add more. Alright, so that's the right side. So we have, sorry, that's the front side. So the right side is complete, front and rear. So next, let me see how much more for the left side thing. I don't know where I put my Sharpie because I should label these right side. If it's not obvious, of course. Alright, looks like probably still a few, like 5 minutes or so. What else should we do next? You know, maybe I can fix up the plate here with some washers. We're going on a little side quest here. These are M3 washers. And so I think if we were to stack 2 washers on each screw, gotta do 3 washers because might as well get it right the first try time. Alright, 3 washers. And I know you can't see. I need a different camera setup. A camera from the top would be great, but I only have 1 camera and that's my iPhone. And I'm not investing in equipment until we get to 500 subs. So let's get 500 subs and you'll be able to see everything. Very annoying having to like line things up in a small enclosure. Good news is that it worked. There's no play anymore. Three washers did it. So now I'm gonna do the other side, just because it's the right thing to do. Kind of like you kind of only need 1, but let's do these things correctly. Let's do these things right. I'm gonna move the wires a little bit so they're out of the way. Basically, like open them up a little bit. I'm curious to see the washer factory. These are very small and thin pieces of metal, and they're basically free. Something just flew away. I have no idea. This one came in easy. And there we have it. It doesn't move anymore, so that's good. Honestly, I'm the happiest about the switch. It's just very smooth. The USB thing, I did screw up the mount, so there's some play. Not super proud about that. We also have a small gap here. It looks like the 3D print might have been detaching from the bed. That's my only explanation. There's gaps on every corner, so they're not perfectly flat. Anyways, I'm gonna pause these and then we'll be back when the jig is done in like, I don't know, like 2 minutes. Alright, so the second I pause these, the print finished actually, and so it's very nice and warm. It's actually very, very, very nice and warm. So this is what it looks like. Looks the same as the other one, of course. It's just a mirror. And I didn't even check if I mirrored correctly. I just used my shape rotating skills in my head to be like, yeah, this must be it. And of course, as an advanced shape rotator, I'm sure I got it right first try. But again, didn't check. You gotta move fast, guys. Can't be checking. Gotta trust your gut. And then the only change I did was add this cutout here, which the other one didn't have. You can see it very clearly here. So it clears on the front end. It clears the servo hop thing. All right, let's get started. Let's do the rear first. Rear left, RL. Rear left would go like that. This would be the hip. So you put this here. Advanced shape rotations. Man, there's some support in the way. I freaking hate support. It's the worst part of 3D printing on a Bambu. The worst part of 3D printing on a normal printer is that it just doesn't work. But on a Bambu, the worst part is that it works, but there's support, man. Maybe I should hire an intern just for the removal support. Anyways, it's done. Okay, so the hip on this side I think goes to 180. So on the other side it was at 0. This side, because it's the left, we went 180. We said 180 was on pin 11, so we set it to 180. And the hip is always the one on the top. I remember that much. Orange part, very nice. All right, and here we go. So you kind of place it like so. No. Yeah. Oh, okay, yes. Like this. Right, like this. And actually, let's make sure we have the correct screws handy. So the two of these are M3s 10mm long. We have them handy here on our table, very organized. I'm being sarcastic. All right, that's in, easy in. Our screws coming. I think that's it. That's basically it. And now we take our advanced shape rotation skills to the knee. The knee is always 90 degrees regardless of the side. 90 degrees in pin pull. We bring our jig. And so we might have encountered some issues with our jig here. We might be getting some interference. Yeah, it's definitely some interference. You see the pinion of the knee servo. Can't access it. And that's what I get for not checking. Now, of course, I have a solution. Advanced shape rotators always have a solution when shape rotating fails. And it's, you just move the, something like, you just move the things out of the way. Not the cleanest solution, but alright, I'll admit not the cleanest solution. I admit this on camera. I'm admitting this to you right now. Will be our secret. I didn't have the most clean solution. But hey, if it works. Alright, so the left side tools still need some work, but I think the leg works and everything is installed as intended. So that's good. See the problem for tomorrow and how to actually walk. Hopefully nothing's wrong. One more leg somewhere here. Okay. Front left. Front left would go somewhere like this, and this will be the hip. We bring our advanced jig. We set our hip to 180 degrees because it's the left side. Pin 11, that's what we said ages ago. I hope you still remember. Wait. Oh, okay. Right? Like this, and this is the hip. So, no, like these, yeah. I'm just looking at here, right? So servo goes here, like it's here. Our cutout worked, so it's no interference with the servo. This cutout, it's nice. Here. Something's in the way. This one seems slightly off, even with the jig. Let me torque it down. Oh, I know why it's off. I didn't connect the right servo to the Arduino. Connected the knee servo instead of the hip servo. That would have been a big oopsie doopsie. Pin 11. Alright, big difference now. Big difference. By the way, something that I'm afraid to admit is that these servos actually get warm. And so one of the tests we need to do is a treadmill test. First of all, to figure out how long the battery lasts when the robot's walking, but also to figure things out like, oh, are the servos gonna get too hot and melt everything around them? Which wasn't a concern I had when we first started, because I've never had that issue with on any project, but it is a concern now. Alright, now we switch to the knee. And we set it to 90 degrees. $90 is in pin 12, of course. And we use our jig, our shape rotator jig, to set these to 90, right there. It looks perfect. Perfecto. Tutto bene. Alright, and that is all our servo initializing stuff. We're done with this Arduino. And now we can just we can get rid of these jigs here. I'm not gonna throw them away, but their mission is done for now. And now we can assemble this stuff here. So this is from left, so it should fit right in here. We route our servos like so. 1 servo, 2 servo, perfecto, and then we come here. We assemble these like so. Where is my, okay, here it is. Too much torque, man. Too much torque. All right. So now we have all the servos coming from here. The only issue, of course, is that all the servo wires are the same color, so it's like, oh, which one's which? Hard to figure out. I did buy some wire sticker label things, but I don't think we need those, right? Like, well, we'll see. I do have them if we need them. I really like this blue shade that we have going on. Very nice. And no, I'm not talking to myself. Also, I'm not talking to a camera. I'm talking to a robot. You know, one of the biggest motivations right now to get the robot going is because I just want to make some TikToks with the robot. Which sounds kind of dumb, but I don't mind telling you the truth, even though it sounds dumb. You gotta own your truth, you know? Like Gen Z says, speak your truth. That's my truth. All right. All right, rear legs are complete, front legs are complete. Now we can merge everything. Now one interesting question is, how do you know which side is front and rear? There's no markings here that would tell you which side is front. We should probably put a little arrow like this for the side front. I know that the battery and the switcher is supposed to be on the right side, which means this would be the front. But I don't know that for a fact. I just have a gut feeling. So let's check. And you know, at the end of the day, it probably doesn't matter. But we like to do things according to CAD. And so I'm just checking CAD real quick here. You can probably see in the mirror behind me. Of course, on shape, went on vacations. It's not working because I don't know. I was away for too long. So here we go. Here we go. Very slow. Okay. I would like to meet the Onshape team at some point and ask them questions of their decisions. USB port should be on the right side. USB port on the right side. So I was wrong. So glad we checked, even though it probably doesn't matter, but all right. So I'm gonna put the rear first. Rear legs coming in. This part is always very cool. It just looks cool. Okay. We're out of screws. Can't find screws. Yeah, when it starts to come together, it's just always a very emotional moment, guys. I get teary. I'm proud, I still remember when it was just a leg. There was no robot. Those were the days. I don't think we'll get to send this guy to Mars though. Let's just say reliability is not there yet. Not Mars reliability. It's more of like maybe go to the port and hope it doesn't fall apart type of reliability right now. Fingers crossed you don't fall apart. Oh, it's heavy. Do you guys want to measure this? You want to see how heavy? Although we should measure the entire thing, but just out of curiosity, you know. Also, it doesn't look as bad as I thought it would look. Almost looks decent. Almost. Still a little chunky. We're at 989 grams. Before putting the front legs on battery, which is heavy. Actually, how much is the battery? Let's measure the battery. The battery is 245 grams. Not as steady as I thought. Okay. You do use a ridiculous amount of screws, which is very good for the screw factory. Oh. It's a little crunchy because of the printing defects that we talked about earlier. This guy is a game changer. Alright, right now 2 more screws. Honestly, probably don't need those, but okie dokie. I think the packaging looks very mature now. Even though like this project just started, but looks good. And this guy still has battery, which is so much better than the last guy. Anyways, everything mechanical is now assembled. So really the next step is to, well, first of all, okay, look at all these wires. So yes, the packaging is cleaner, but still a few too many wires. There are things we can do about these for sure. For the first thing, I'm just going to use this wire management stuff that came with the USB-C and pair the wires from the single servo together. Just so I don't lose it during installation, you know. When there's too many wires, the voices in my head start to go crazy. Okay, so that's basically what we're working on with, and these, and then we gotta flip it to do the wires at the back side. So I think, I mean, the first thing we should probably do is like bus bars to servos. That was pretty easy, and that was like a ton of stuff that needs to happen. Now, working on the robot on this side is easy, but working on this side is not as easy because there's no nice surface. Oh, actually, It kind of works. It looks funny. Alright. So we're rebuilding our previous wire mess, so our 28 wires. And basically, the way I remember these is anything that's black, gray, or white is ground. And I think brown is also, there's no brown, there's one brown. Maybe I'm colorblind. Is that brown? Yeah. So there should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 grounds. And then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Let me count that again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You see, you count again and now you have the right amount. It's magic. Alright. So I want to put those on the ground side. There's an A and B on these bus bars we're using. I'm going to assume from now on anything that's B, it's ground. I might do some close-ups shots after, because like if this actually turns out the way I want it to turn out, I think it's going to be very clean. Alright. This looks already so much cleaner. Just the wiring looks so much cleaner than what we had last time. Which, you know, maybe it isn't saying much, but almost like, you know, building something you're proud of actually feels very good. Building something that you know you did it, you put some effort in, you tried hard, feels good. And if someone doesn't like it, or if this fails, I'll be like, oh, actually, I didn't try that hard. You can always try hard. Now, for all the electrical stuff, I'm going manual on the screwdriver. Just because all this stuff is so small, you know, don't want to break. Also, having a short on the power stack could be catastrophic, like literally catastrophic, like apartment burns down catastrophic level. And so basically that's what we have now. Something fell, I don't know. And then we can start routing 3 at a time on these 3 here, 3 here, 3 here, 3 here. And we kind of have those fingers. Each finger is for 1 servo. That's why each cutout has 3 fingers. So we can try to be systematic about it. And basically go in order. First one on the first cutout, first finger, second one, first cutout, second finger, and so on. So you want to make sure there's space in between the fingers. Looks like it. Can't tell if the fingers are fused or not. Maybe a little bit. Some encouragement. Just encouraging them with my giant knife to open. Being very nice. Oh. Man, there's support chunks all over my floor. I wonder if my girlfriend's gonna notice. Like, hey, all sorts of microplastic green chunks on the floor. What's up with that? Alright, some of these fingers are definitely fused together. We could add some gap. Alright, that's it. Now we're going systematically. 1. Can you stand on your butt like this? No. Alright, maybe the fingers are actually too tight for wires to go through. Okay, well that's one wire in. It wasn't easy. Those fingers are a little tight. But it is looking very good. I want to show you right now. Alright, so, well, I'm not sure what you can see actually, but basically, routing everything through here. And so we put them through like these fingers, and then on the other side, you see them coming through these fingers here. And so right now there's only grounds, but each finger can hold up to 3 cables according to CAT. And so it's very easy to see what goes into each servo, kind of thing. Maybe. This is the first time we put some thought into the electrical wiring. I mean, it is a lot of wires. I do hope we can eventually move to a power PCB. I don't have to think of wires. It's wires. I mean, I've always hated wires. It's not just a new thing. I always thought wires were lame, so. Now, what's worse? What's worse, guys? Real question here. What's worse? Wires or removing support? That's a tough one. The main reason for that is just you cannot mess up support too much. I mean, sure, maybe you break the part like I did earlier, and then you just bring a new one. It's like not the end of the world. But with wires, oh man, so many things could go wrong. Yeah, I basically complain about every step of assembly actually. Now that I come to think about it, it's like, if we're doing support, oh, too much support. If we're doing screws, oh, too many screws. You guys must think I just complain. It would be nice if this wasn't as sharp, because I'm kind of like damaging the wires. Alright, only 3 more to go. Almost done. And that's only ground actually. We still need to do power and PLVM. Actually only power. PLVM doesn't come through it down here. Which is fine because I size these fingers to grab 3 wires, thinking that PLVM would come down here, but it doesn't. So. Oh, I have like stuff like pliers here. whatever you call these things. Alright, I got much better at doing that towards the end. And so now we spin this around. I need to make sure this doesn't get as bad as last time. So I'm gonna do my best to keep everything very short. Trying to keep everything symmetric, right? So if on the left, the first wire coming through the fingers goes to the shoulder servo, do that on the right as well. So everything has an order. You can kind of tell which wire goes to which servo just based on the length. The longest one is shoulder because it's right there. The second longest one is, I think it's usually the knee. And then the least long is the hip. So it's the furthest away possible. Alright, that's the grounds. Grounds are in. This really is the kind of thing that you hope to do only once and then don't have to ever do again. It's very annoying. Some of these wires are also way too long for what we're doing here. Alright, now we do power, the other side of the bus bar. And for power, I think we did red, orange, and yellow. Red, orange, yellow. 4, 5, 6, 7, 8, 9. Kind of missing some wires. Wait, so we have 1, 2, 3, 6, 8, 9. We need 3 more. I do have more wires here. So we can do 3 more. And that's it. Those are all the wires we need. Now I'm trying, since we're mixing colors, I'm trying to start with all, the first ones are reds and then the oranges all together and so on. Again, just to keep things a little more consistent. Now these wires are a little harder to reach because we are coming from the undercut of this angle in here. It's not a huge deal, but it's like these little things that make things less ergonomic actually add up. Ergonomics when assembling things, super crucial, super important. Especially if you're the guy assembling the thing. Extra crucial, extra important. Alright, another way of doing this would be to put the wires on the bus bar before nailing down the bus bar to the body. That's an assembly shortcut for sure. You still need to be able to service these in the robot, ideally, without removing the bus bar. But, maybe I have too many best practices. Maybe I should just build, It's like kind of like spaghetti code, but like the equivalent is spaghetti robot. Just like do whatever. Tactic things. Yeah, it kind of sucks to assemble, but it works. I am a little bit concerned how thin these wires are to power the servos, but like I said, the servos themselves have thin wires, so it doesn't get much better. Unless we move away from servos, which it's coming. Like sometime in the future, we will do that. Okay, that's all the wires on the busbar side of things. And now I go through the same exercise of routing these things through onto the other side. Fun. I broke a finger. Nice. That was bound to happen, I guess. Alright. Onwards. Try not to break anything else. These fingers are definitely too tight though. I think I basically just broke another finger there. Alright, maybe change of tools, right? Like how many times do you do the same mistake before you're like, oh, maybe I should change. I regret these. And by these, what I mean is the idea of having these fingers without first validating the size. I just gotta move fast, you know? No point in rushing if I'm just gonna do a bad job. It feels like doing surgery. Actually, I've never done that before, so I don't know. But I'm basically on these robots hard, routing little wires. 9 done, 3 to go. Doing surgery minus the doctor's salary. And yeah, I really wish I had another camera to show you guys what's happening here, because I think I've verbally explained, but basically trying to wire these, trying to route these wires for these little finger features. But they're very small. The wire doesn't go through, so you gotta open it with a screwdriver, and then with another screwdriver push the wire in, and then it holds in place. It goes here. It's kind of hard. I'm gonna take a quick break. Break is over. What would Elon do? Elon wouldn't take breaks. I'm gonna try a different strategy here. I'm gonna try to push it from both sides at the same time. And that worked. Nice. Wow, what Elon do always works. Okay, this guy doesn't want to stay upright. Doesn't want to work again. All right, and the last one more. It's nothing, just one more. Boom. Done. That's all the servo wires. Anything that has to go through fingers is done. Now let's actually connect them to the servos. It looks so messy. Like there's so many wires here. I don't know what to tell you guys. Maybe I just move my existing camera around so you guys can see. I just think wiring is the worst part of everything. It's worse than everything else. Worse than doing screws with no electrical screwdriver. It's worse than removing support. It's worse than troubleshooting firmware. It's just the worst thing. It just doesn't get worse than these. I feel sorry for the electrical engineers. I guess they even themselves don't like hot wires. That's why we have the PCBs. Some of these feel a little tight. I guess they are kind of tight. So we have some wires that are too long, some that are too tight. Anyways, continue. I think despite our efforts to clean up wiring underneath and connecting the PCBs to the frame and stuff like that, we're still gonna have a ton of wires at the top. It's still gonna look like spaghetti. And that's mostly because of the freaking servos, man. Those wires are so long. Alright, so servo power is done. That doesn't mean we can power the servos yet. And so here on the top, very messy. We can clean it up a little bit. Here at the bottom, not as messy, actually looks decent. You can sort of tell what's going on. We should probably do. Things keep falling. I don't know what's falling. We can do bus bar next. Bus bar. So buck converter to bus bar. So for the first time here, we're gonna open our new wires. This is all the electrical stuff I have. All right. And so this was pretty simple. We're looking to connect these two terminals up here, coming out of the buck converter, send them downstairs, and onto the bus bar here, this terminal. So it's kind of short, and it's power related, so of course we're gonna go with black and red, right? Red is positive, black is negative. I don't even know if you're allowed to say that in 2024. Space gray and red. Alright. And I'm gonna sort of attempt to measure the length. Yeah, see, it would be nice if we could stand on its butt. See if the CG helps. Okay. Attempt to measure the length of these, and something like that. It's very short. We're gonna cut here. Giving a little extra always. You never know. Just in case. Not in case that we need more, but in case I screw up one of the connectors, the crimping. That's what I mean. You never know. All right, now this wire is 16 gauge, I think. Sorry, it doesn't say. It's 16 gauge, and we have our crimpers here that can crimp stuff, and we have our connectors here that can connect stuff. Now the connectors are red, blue, or yellow, and these are not color preferences. These are color coded to size. So red is for anything between 22 and 16 gauge. And then we have blue for anything between 16 and 14 gauge. So we're right in between blue and red. So which is fun. That's a fun area to be, because you never know which ones you should be using. So first of all, what actually fits in our buck converter, right? So I'm just testing out to see if this connector would fit, and it's too big. It doesn't fit. We do have some rings here, which could fit if we remove the screw and put it back. I think we can do that. Yeah, we can. It's just very messy. Okay, these little red things will work. Or the blue ones would also work. And that's at the top. At the bottom, different story. Man, I don't think that anything will work there. That thing is so small. Like, I mean the bus bar, it's so small. I don't know if we have anything that will fit. But then if we don't fit anything, this is the thing that keeps on melting, so. Man. What about these? We could also just raw dog some wire in here. It is thicker wire this time around, so maybe we just tin the wire and like put it in there. Right? It's probably what we have to do. It's probably no choice. No other. Yeah, that's probably what we're gonna do. All right, but on the other side, we do want our red clips, these things. So the way you do this, basically, you're putting some screw, some wire through here, and then crimping it. And so you just come here and I don't know, it's hard to tell how much you need to remove. Yeah, you put it all the way through, and then you come here and it. That feels very solid. It's great. And then you do the same thing here. done. And then, I mean, okay, so the other thing, what I was saying is like, how do we actually get these other wires to go into the bus bar? Since that is very tight. And the best idea right now is to basically strip the wires and put solder. What's called tinning the wires. So I'm gonna try that. So we need to get the soldering iron out, which is exactly what I was trying to avoid, but here we go. So this is what my final wires look like. You won't focus on them. Man, just picture wires with solder around them, so it's like the strands will not come apart or anything. And so first of all, let's see if it fits. These solders are not super clean because my soldering iron didn't get hot enough. That's my mistake because I was using a soldering chip that was too thin. When they're too thin, they don't have a lot of thermal mass, so they get cool quickly when they come in contact with something. That's something, for example, it could be a thick wire. Alright, these guys are too thick, they don't want to go in. Plan B is to just go with wires, but that feels risky, man. This video could be called "A Mechanical Engineer Navigates Electrical Wiring." Yeah, this thing simply doesn't fit. This bus bar slot is really not that big. Very frustrating. I actually have another bus bar, so we can check how far off we are. Can't really see it when it's in there. I have another one here, just to see what I'm trying to do, the feet of what I'm trying to do. Yeah, it won't fit. But nothing will fit. I'm not sure what kind of connector we could use. Like, this is so small. We could try to modify one of our connectors here by like folding it in half or something. But that's tough. We could also try going pure wire. Just bare wire, you know. There, let me see what that'll look like. Bare wire is risky because it's not what it can always slide off and stuff like that, you know. I need this to never fail. So we can do bare wire. Bare wire super tight, and then we try to pull it off. Can't really pull it off. Okay, I'm kind of like in favor of bare wire. It's the best option we have right now, so gonna do bare wire. let's remember this moment in case the robot burns down later. And that's the moment we decided to do bare wire. And nothing was ever the same. It's not only bare wire, it's also bare wire, and I can't really see much. Alright, it seems on, it seems it's in. This is for the positive, and now here comes negative. Red key. I think so. I think it's fine. At this time we can check with our voltmeter to see if there are any shorts. Basically, our resistance shouldn't be 0 across them, right? So you can test your probes here. Low resistance, and then you can test here. Not 0. Anyways, I think it's fine. Doesn't look like a short. And so now we just route these on up to the second level here. Just push them through this hole. And now we have them here. Spaghetti. The buck converter has a positive and a negative, and you just gotta find them, and then just like screw these on. So on the bus converter, I feel pretty good. These are screws. This doesn't feel like it's gonna go anywhere. It's the bus bar side that I'm a little worried. Just because I usually try not to go bare wire into a terminal. Really, I want to have modules, so like I can create different robots, but I don't have to worry about wiring and stuff like that. We just have some modules that we can use for power and stuff like that. We don't have to worry about all these things. Anyways, now that's the bus bar. Bus bar is complete. So there's a couple of things to do here. Actually, let me close the window. The freaking train is so loud. Alright, there's two things to be done here. One is the PWM for the servos, and then the other one would be the battery. The battery is the switch. PWM for servos and battery switch. That's it. After that, we can actually move. Now for the battery switch, we have this guy on the back converter, pure wire onto the back converter. We've had that guy fault before, so I'm gonna take that off and then I'm gonna switch out two connectors. But before I can switch that to a connector, I need to add also a switch onto the positive of that wire. Alright, so that should be off. Alright, so it's this guy here. This guy is 12 gauge. And the negative side, we can just, I'm gonna cut off the ends, they're dirty. The negative side, we can just put it straight onto a connector, I think. And then the positive side, we'll use a switch. So for 12 gauge, we use the yellow stuff. And so we can just put the yellow stuff here. This is very big stuff compared to everything else we have here. Not big in like the actual sense. If you work on EVs, there's a lot of stuff that will be bigger than this. All right. I think that looks good. So at least for the negative, that was easy. Now for the positive, I don't know where I put the switches, but the switch thing came with some stuff, some like connectors and stuff. Yeah, so here are the switches, rocker switch, and they come with these blade connectors that go into the switch directly. There's black and red. It's all positive, but black and red. What gauge? It doesn't say gauge. There's actually readings in Chinese here. So this positive guy would connect to this positive guy. And this positive guy is very thick, this one's very thin. And so I don't know if we can mix and match a big one and a small connector. Probably not, honestly. Oh, yeah, you can. That's nice. Cool. It doesn't only mix and match, it also doesn't come off once it connects. Then we have also these, they call them bullet connectors. And I think these ones do come off. These are all very strong. I honestly don't care which kind you go with. Anyways, he's gonna crimp onto this guy. I think that'll be good. I don't see why this wouldn't work. Alright. Oh, I was able to pull it right off. Not a good sign. Should not be able to pull off a crimp off just like that. I'm gonna peel the wire a little bit more and try again. I mean, these are 12 gauge. Yeah, they should definitely work. And that looks good. It's like not like I would pull it super hard good, but it looks good. Then this guy here, I wonder how much this is rated for. So this looks very thin, so I'm gonna go with the red stuff. We don't know what gauge this is, so this red stuff here. Okay, and then you connect it like this, and that's connected, and then you can just connect this to the switch. I don't know if the switches have a positive and negative. I think they don't. I don't think it matters. Then the other end of the switch you connect to the terminal. Yeah. Is that long enough? Yeah, probably long enough. I know I might be appearing nonchalant about these, but I am pretty sure about what I'm doing here. Professional, I'm a professional, means. I've set things on fire for getting the right routing wrong many times. So I really respect electrical, especially when it comes to powering stuff. So if anything goes wrong here, I'll be very surprised because I think we're doing things correctly. All right, that should do it. I kind of lost the screw for the buck converter, possibly. Oh, there it is. I'm definitely gonna. Well, I don't know how interesting it is. This wiring section, I don't know how interesting it might be. I think next time we wire, we'll put the camera from the top. Why would you rather see my face or the wires? Be honest. Oh. Man, wiring on tight space has to be one of the worst things. Do not recommend. I think it's gonna work. I might be stressing this back converter a little bit. Mechanical stress though, not like electrical stress. But it's like the isolating walls around the terminals are like stretching because my connectors are too big. Whose fault is that really? Like, who made that wall so small? Come on, guys. Especially for a back converter that can handle this much current. Alright, it's on. It looks a little dirty, but it's on. Voltmeter, make sure nothing shorted there, just because it looks a little tight. Always touch, make sure we have a 0. Close to 0. Check. That's great. no shorting there. Next thing, we can check how the switch works by putting our probes here. Alright, so the little stick means on, and the other one's off. I'm gonna write that with a Sharpie, if I can find a Sharpie. I really don't know where the Sharpies go. It's like I have a Sharpie for a video and then it disappears. Alright, found the Sharpie, it was on the floor. I'm just gonna write on here. I feel like it's a safety thing. It's good to know where it's on. Okay, so with that in mind, so this is what it looks like now. There, looks like in the back here. I do agree there's too much wiring going on. I was gonna say we're missing the thing to strap down the battery. Let me see if I have it here. So more of these from drones. So drones usually use kind of like a Velcro strip to strap down things. And I think I have some extra ones. Or I thought I did. Alright, so this is the Velcro strip that drones use to tie up their batteries. And so I made this loop thing here at the bottom. And you basically just loop this underneath. And like that, and then your LiPo is in there, and inside that loop. And that's it. That's what's gonna hold the battery. Works for drones, it'll work for these. Alright, so as a next step, I just want to power everything and see what happens. So I'm going to plug in the battery. I feel like if something's going to explode, I would rather have it explode now than later. Then after doing the PWM stuff, because there'll be more stuff to clean up. Alright, here we go. So I think the servo, the Arduino should be, Arduino is on. The back converter has its lights. Everything looks good. I'm gonna turn it off. Oh, actually, let's turn it off with the switch, see what happens. Yep, everything's off. Switch works. Back to on. Nice. So the switch works, and we didn't mess up anything electrical. So two wins right there. So now we're just gonna finish with the PWM for the servos, and after that we're basically done. We can walk. So we're basically repeating that whole video of like, oh, first time walking and stuff like that. But yeah, I mean, it did take a while to get here, but you can see that this robot is a better iteration than what the previous robot was. I mean, the fact that we have a switch, a USB port, things are tidy, everything's, nothing falls off when you flip it. Hi. All right, I got, my girlfriend got home, so I had to stop for a little bit. I'm doing this in the middle of our kitchen, so it's kind of like gets in the way. But anyways, let's continue. So we're basically almost done here. The last step is to do PWM. So we need 12 PWM wires on the Arduino side. And once that's done, I can move off the kitchen table onto the floor, because the next step is to move the actuators and make sure everything's working correctly. So let's find 12 jumper cables here. So 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So these are our jumpers. Now previously we had something, an order for which pin goes to where, but this time around I think we don't need that. We can redefine which pin is, the shoulder and so on. So none of our old code is going to carry over, but that's fine. It's very simple code anyway, so I don't mind rewriting from scratch. Let's put in stuff here. So all I'm doing is connecting jumper cables to the digital pins on the Arduino. We have 12 servos, so we need 12 pins. And fortunately, the Arduino Uno has 14 digital pins. Now, 2 of those digital pins are a TX RX. And so that means that if you were to initialize the serial monitor, for example, so you can see commands that are being sent out of the Arduino to the serial port, the USB to your computer. That would get in the way with the servo, so you're going to see a lot of the servos tweaking basically. And on the other, there's also an RX pin where it would also get in the way if you're sending commands through serial comms. So in reality, yes, there's 14 digital pins, but there's basically 12 that you can use without any issues for the purposes of servos. Now, of course, we could also just simply not initialize the serial terminal. Also an option. But in this case, we can just let pin 0 and 1 alone. So in the future, if we do want to use the serial terminal for something else, we can. Alright, so these are all our wires. Trying to find some order here. This is a real mess. Yeah, I think it really pays off to keep your wires very tidy. So maybe I want to write this down. I'll write this down on my phone or something, but recording from my phone, so I might write this down on paper. Not like I have a lot of paper around, but alright, found some papers. I'm writing this down just so we can later use this to write code. Basically, I just want to know which pin is connected where. We're starting from pin 13 all the way to pin 2. So 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2. There are so many things in this table, it's getting annoying. So 13, we're gonna go the servo bundle here. 13 is gonna be rear right shoulder. So I'm just gonna write this down. Rear right shoulder, right? So we're obviously working in groups of 3, since it's 3 servo motors per limb. And then 12 is gonna be the hip. It's gonna be rear right hip. And so by this cartridge, 11 needs to be the knee. And like, if I get this wrong, not a big deal, you know, can come back and fix it, but ideally don't get it wrong, you know, just get it right, just do it right. Take your time, do it right. All right, next. Now we're gonna do the rear left. So we're looking for the rear left shoulder. We found it. And so I'm gonna write this down. Shoulder. Now we're looking for that rear left hip. And then the rear left knee. And now all the rear actuators are accounted for. It's this wire mesh over here, right? So if we can separate the wire mesh from the rear here, everything else is going to the front. It's kind of hard to manage these wires because everything's a different length. I don't know, is this a problem for later? Also, I feel like later means never. Alright, anyways, let's keep making connections. So we should be on pin 7. And we're looking for the front right shoulder. Found it. Maybe I'll ask on Reddit if anyone has any ideas for how to do better wire management. Pin 6, front right hip. That's the hip. Pin 5. Should be front right knee. So that's the knee. And so now pin 4, 3, and 2, they'll be front left, where pin 4 should be the front left shoulder. So this guy should be here. Pin 2 should be the front left hip. And then the last one is the the knee, of course. Hip and knee. And that concludes basically assembly. This robot is now fully assembled. It has all the wiring needed. Now it just needs some code. As usual, the first thing we're gonna do is we're gonna try to get it to just like stand. We'll start there. And then we're gonna put all the legs off the floor and move them at the same time. Run it for maybe like a minute. See if anything gets too hot. I guess the last thing I didn't do was strap the battery in here. So maybe we can do like we can weight it. Oh, guess what? This is also very tight. Shocker. Everything on this robot is just so tight. To be fair, that's not unique to this robot. When I work on drones, that's also very tight. And I think having a tight package is worth it. Man, this thing is, this connector is like no slack whatsoever. So in practice that feels fine. The concern that I have in mind is like, oh, what happens if I need to remove the battery really quick because there's a fire? So I guess we had all the firmware installed. I just turn on the Arduino. I'm gonna move to the ground. All right. All right. So this is our setup here. I'm gonna connect. Yes, that works. Here's some high-pitched noises, which is not good. It means the Arduino is trying to move the servos. So first step would be to put some empty code onto our Arduino so it stops trying to move. It's uploading, done uploading. Okay, now we can power this on. I don't know why it does that, why it's so stiff. It's like by default, it doesn't want to move anything. Now we're gonna try to move the rear right shoulder first. So I'm gonna write code manually with no GPT this time around. Gonna set the rear right shoulder to 45 degrees. This guy, 45 degrees. Now the other way, 135 degrees. So, all right. All right, back to 90 degrees. I'm just writing code now for the rest of the actuators and adding labels. So I know where everything is. So now we're gonna move the hip. 45 degrees. So the hip the rear right hip 45 degrees. So they should move, yeah. That's good. Just doing a quick temperature check. I mean, it's too soon for anything to start breaking, to be honest, but. All right. And let's move the knee. The knee's kind of tricky. We since we changed how we initialize the servos, there's no. Okay, that knee didn't move. We don't have safety envelopes for which angles. I'm trying to move the knee and it's not moving. Let's check the wiring on that knee. It looks like it's powered. I hear a lot of high-pitched noise. Okay, so the knee doesn't want to move for some reason. Almost feels like the knee's stuck. I don't know why. Let me initialize some more servos. Oh, I see what's the issue. It's a firmware issue. My bad. So now the knee should move. Yeah. I moved it too much, but. Okay, all right, not bad. Let me initialize some more stuff. Honestly, writing the code by hand is not as bad. It's not bad. Maybe I don't need ChatGPT after all. Again, the code for this is very simple. I should probably record my screen. Basically, all I'm doing here is initializing the servos. So you basically say, okay, this servo number 1 is in this pin. So servo number 1 is in pin 1. That's how I'm naming it. So everything makes sense. And then you can initialize the servo to a position. So, when it's on, set it to this this degree. And then I'm also adding nodes for what goes where, basically. And this is all on the Arduino IDE, so I think it's very basic. Once we do something more interesting on the next video, which is gonna be tomorrow for me, I'll record my screen. I need to figure out a way to record both my screen and the robot. It's making noises. I don't know why it's making noises. So I'm gonna initialize all the shoulders to 90 degrees, which is basically what they're at right now. and I'm gonna push that code to the Arduino. Bit of a stall here. I made a coding mistake. I normally don't write C. I'm normally a Python person, which is a terrible excuse, but pretty sure we got it right this time. Looks like our Arduino might have tripped. Computer is not recognizing it. Buck converter is getting hot, but it also has a giant heatsink. Bus bar is like warm, I wouldn't say it's hot. And switch is not even warm. So I think it's good. Okay. All right, so now we can have some more. I just initialized. Oh, sorry. I just initialized shoulders to 90 degrees, which is default position. And then I'm gonna say initialize legs to standing position, right? So servo 12, right? So let's see what would be a good standing position for the rear right leg. So 0 is here, right? So maybe like 45, and then its knee, something like 120. Let's try that. Oh my god, I missed a semicolon. Let's try that. Would you say that's standing? A little more knee, right? Maybe 130 on the knee. Yeah, what do you call that standing? Let's see what happens if the front also does that. We might have initialized that wrong. Let's see, what went wrong here? Front right hip. So this thinks this is 0. And if that's 0, what does it think it's 180? Oh my god, that was bad. Oh, that was bad. I think this guy is gone. Interesting. I don't know why. Yeah, how did I get that wrong? I'm a little puzzled. Let's see if we can at least save the knee. I missed the semicolon. Alright, so the knee seems to also be off. I do not understand. Just writing some notes here. These seems to be way off. Alright, I'm gonna move on to the next joint. So at the left side, front left. Let's do front left. So front left. Front left hip would be 135. Let's see. Well, let's start there. Let's see if anything gets right. I feel like that did nothing, but okay. And then the knee. Would be 50 degrees. I made a typo, uploading. Okay. It seems very odd. That is not the way I thought the knee would move. I mean, I don't understand. Did I mess up the initialization so bad? It feels like hard to mess it up that bad. These guys should not be going up like that. So this is 90, this is where I initialized it to. It is a little off. I also think this guy can move even when I think I have moved the servos too hard, because look, this rotates without me even like moving. So I think we've stripped that actuator, whereas like this doesn't move at all. This can just move freely. So I might have stripped that one. These servos are very violent. Let's try the rear left. So servo 9 right, 135, and servo 9 right, 90. Oh. Okay, rear left. Okay, again, this is supposed to be, oh. This is supposed to be 180, which is what I initialized it to, where this was supposed to be horizontal. So this is way off. So it's like it has drifted a lot. So it's like, you can't even trust where, oh my god, yeah, see, like I think this is stripped also. or it's not tight enough. Let's bring the screwdriver. It's possible that I didn't tie these enough. Okay. Well, I think what I'm gonna do is I want to print new servo horns. I mean, first of all, we have it working, right? So it's little problem with initializing the servos, but the robot works. It's on now. Electronics are working. Nothing's overheating. And the packaging looks good. But yeah, it looks like we have a little issue with initializing the servos. It's already 7 p.m. so we've been going for a full day. I'm gonna print new servo horns so we have fresh servo horns, and then because I think we've stripped some, and then the plan starting tomorrow, so next video, will be to repeat the exercise we did a while back where we identified a safety envelope. So, for these, when the hip is in this angle, the knee can be in these angles and so on. So we make sure to never hit the hard stops, which can cause the servos to strip the plastic. So we're gonna do that, and we take it from there. The last thing I want to do in this video, just to finish with the hardware for good, because I think it's in a good spot. I wanted to add this anti-slip, like 3M tape I got from AliExpress. It's a double-coated tissue tape, and we could add it here to the feet for extra traction. This was like $2 from AliExpress, and I have vinyl floors, so traction has been an issue. I think with these, it's no more of an issue. We will see. But other than that, I'm very happy with where the hardware is right now. I really like this new iteration. Oh, this feels good. It's like soft. It's a sticker. I don't know if it's gonna actually stay there, but yeah, I really like this new iteration. The new packaging looks great. The new color looks great. The new legs look great. But it's always kind of like the software part that gets me. So that's really where I need to spend more time developing the firmware. And so that is the plan from now on. There are no more to-dos around the hardware unless something was terribly wrong. But from now on, it should be just getting this thing to walk. And once we have it hard-coded to walk, we're gonna build a joystick to control it. But that will be the whole video for today. Thanks a lot for watching, and I'll see you next time.